topic that I kind of discovered for myself over 20 years ago. And I've been telling this story before, so bear with me if you've heard that before, but every year I'm kind of expecting that I would need to look for some other topic to work on because, I mean, web app security, that's not that hard, I think. And therefore, the situation should get better. But the situation does not get better for obvious reasons and not so obvious reasons. And one of the trends in web app security is that the teams behind web browsers, they also understand that the situation is horrible and that supposedly we developers, can't get our stuff together. There are still security issues, so they are continuously adding security features into their software products. So the idea of the talk now is to give you a run through many of the security features in browsers, many of them HTTP headers, but also some JavaScript APIs and more. So if you expect an inspiring talk with vague suggestions what to do next, you may be wrong here, but if you want to have an elaborate checklist of things to add to your web application to increase the security posture of your site, then you're at the right place. And with that, I'd like to start with an attack that's over 25 years old. And the attack has a term coined by the Internet Explorer team. That's how old it is. What is it? Yes, it's cross-site scripting. Now, I went to cvdetails.com, a website that kind of collects common vulnerability enumerations and also creates nice charts how commonplace web application risk or web application attack is by enumerating the times that there is a CVE for that specific thread. Now here's the chart for cross-site scripting. And I mean, people keep telling me, yeah, cross-site scripting, that's a problem solved. But if you look at the chart, I mean, I'm not an expert, but I do see some increase in numbers. And if you look at 2024, we are not even halfway through this year. But if you double the current numbers, so I took this chart sometime last week, we'll have a new record number, maybe even crossing 6,000 reported cross-site scripting CVEs this year. So the situation is horrendous. And of course, many frameworks and especially SPA technologies, what they do is they try to build in cross-site scripting mitigations. So even if you have no clue about security, then you have some level of protection. But of course, it's mandatory to have a clue about security to go from maybe 95% protected to 100% protected. And the actual reason why cross-site scripting is such a big problem is the one sole security feature we have in JavaScript, the so-called same origin policy. Now, I don't like that term because when we talk about origin, at least but I mean, English is not my first language. So, but I think about, where something is coming from, but no, that's wrong. They use origin here as a term defined by the Internet Engineering Task Force. And origin is a part of the URL. It's the protocol, the scheme, and if it's not the default, it's the port. And essentially, the same origin policy states that JavaScript code can only access things, quote unquote, that have the same origin. Origin as in the IETF definition of origin, which essentially means if you have an iframe on your page and that has the URL in there has the same origin as the outer URL, then JavaScript has access to that. That's a good thing, but if we have cross-site scripting, that means that someone injects us JavaScript code, inline JavaScript code, or JavaScript code coming from somewhere else, a script tag with src set to some third-party server, maybe under the attacker's control. Now, even though that code lies on a different server, since it is injected into our page, thanks to the same origin policy, it has the same privileges as our own JavaScript code. It's like having a new developer on our team, and that developer can pass code reviews, right? That's what cross-site scripting is. Now, I assume that some of you would like to be in that position, but I think that's a different story. But in general, cross-site scripting just means someone is adding code to our application. Now, as you've seen from the chart, cross-site scripting has been there for a long time, but somehow the numbers are still going up, although cross-site scripting offenses are common knowledge, I would say. Therefore, web browsers try to add protection to their systems. So the older people in the room maybe have seen this Internet Explorer pop up, right? IE has modified this page to help prevent, okay, that's lawyer speak, right? So we don't guarantee anything. Help prevent cross-site scripting. And indeed, there were cross-site scripting filters. They originated in IE8, a great browser from a security perspective, because really it sparked a lot of new approaches that other browsers then also included. And well, all browsers except for Firefox, essentially. A filter that had to be fast, otherwise users would complain, and should not provide or report any false positives, because then users would complain. So it was fast and not good. So these were the two design goals of that browser protection, and therefore the protection was always insufficient. Essentially, Firefox was right. Eventually, IE and Chrome, Safari, Old Edge, New Edge, they all removed that feature because there was something, well, new. It's not really new, but it was a kind of a replacement for that, speculating filter. It was something that could give developers of web application control over the execution context, so to speak, of the JavaScript code in the browser. So content security policy is a W3C initiative. It originated with several browser developers working together. Nowadays, staff from Google is helming that. There's a version 1, which was a candidate recommendation 12 years ago. So really, old idea, actually. But then it was demoted to a working node. Working node is like, scribbling something on a piece of paper and then putting it in the trash. That's what a working node is. Because version 2 of content security policy became a W3C recommendation, so a standard in 2016, and that version 2 has support everywhere. All modern browsers have it. The only browser that doesn't have it is IE11, but as I said, all modern browsers have it, so all is good. There is a new version 3 being worked on, which adds interesting new features, but that's, as I mentioned, an effort that is helmed by folks from Google, and it's still a working draft. Therefore, all browsers that are not based on Chromium, so everything but Chrome, Samsung Internet Browser, Opera, Edge, they are hesitant to implement those features because things could just change on the spur of the moment, and they won't take that risk, right? So they are waiting with version 3 features. That's why I only would recommend using version 2, or at least make sure that your content security policy is compatible with version 2 so that version 2 compliant browsers can support it. Now, how does such a content security policy look like? I'll just give you an example. You send an HTTP header. There are other options as well, but that's the best bet. You're sending an HTTP header. The header is called content-security-policy, and then you can have a value, and the value may consist of an arbitrary number of so-called directives. Directives are the things with the hyphens in them. So default SRC, image SRC. And each of those directives may have a more or less arbitrary number of values. The values are separated by spaces. That's basically the B and F, so to speak, of content security policy. And even if you've never seen this before, looking at that, you immediately have a hunch what is going on here, right? So default SRC basically says, okay, if you have any resources on that current page, you can only load it from self. Self is a constant, single quotes mean constants, and means the current, there's the term again, origin. So only load stuff from your own origin. So if someone finds a cross-site scripting vulnerability and injects script src equals http third-party attacker server.no /bad-script.js, that would not be loaded because that's not self. Default SRC applies to any kind of resource, but for specific types of resources, you can have specific directives. For instance, here is the image SRC directive, And I don't think you need much fantasy to find out what that is referring to. So if you load images on your page, now you can only load them from self and from HTTPS staticexample.com, right? So this is really content security policy in a nutshell. So I have an enterprise app here, which I'm pretty fond of because it's using a microservices approach to implement or provide great value. And I made that app, which, I mean, as you see from the output, is super simple, right? We have the current time and we have some awesome design in there. But I made it that way so that everything that can go wrong when implementing a content security policy will go wrong, right? Just not to show you that content security policy is cumbersome. No, it's not if your application is built in a good way. But if you have a legacy application that's maybe, shows its age, then there might be some loops to jump through, and I'll just, show you what needs to be done. The application is actually implemented in a relatively simple fashion. So I have an HTML view here. Actually, I'm lifting the logo from the venue where we are at, from the Oslo Spectrum website, so I don't have to pay for hosting, right? Because I'm stingy, and also I thought, I can up the design a little bit by providing a little bit of color and sizing it appropriately. Then I have the placeholder for the output of the current time, and then I'm loading a templating engine because enterprise applications do need templating engines, and then I'm loading some custom JavaScript code, and that custom JavaScript code, essentially what it does is it is calling a microservice, right, and then that microservice returns the current time, and then that current time is sent to the templating engine, and then the templating engine generates the HTML, and then the HTML is injected into the page. That's essentially what's happening here. So every 1,000 milliseconds, a new request to my API is sent. We get the current time, and then the UI is updated. So that's how things look like. Now, if I'm naive and just say, I just work with a content security policy here, so we can just use default src single quotes self, right? Which just says, okay, load everything from the current origin only, which is a good start. Then if I refresh this, we already see what has happened, right? The image is gone, the color is gone, and most importantly, current time is smaller than before, right? Which irritates me quite a bit. Oh yeah, and the current time isn't there either. So what went wrong here? And again, if you do it right, content security policy is, if you ask me, mandatory because it provides great cross-site scripting abuse protection. I have to phrase this carefully. But depending on the app, there might be some work involved to get the content security policy up and running. It's easier than a new project. You just start with a content security policy. Now, what went wrong here? I mean, there are different reasons. I just would like to give you a glimpse. In general, it's, of course, a good idea to precisely know where your application is loading resources from. For business applications, that's often easier because maybe they're running an intranet, so basically you have one origin only. For publicly facing web apps, that might be a little bit different because, the marketing team just, while you were away for a week, was sneaking in some tracking pixels. And then, of course, that means stuff is loaded from a different origin. So the content security policy has to care for that, or just marketing is wondering why you get zero tracking. But again, different discussion which you have to do internally. Now, of course, the first glaring mistake is that, I'm loading the image from a third-party server. That third-party server is not part of our content security policy because it's not self. So we try to be as specific as possible. So I'm allowing images from self because I may have a fav icon and from everything within that folder, right? So that would be a good idea. And then if we try to reload the page again, Yeah, the image is there, but somehow the beautiful goldenrod color has gone. Still, I'm getting no time output, so something is off. And that leads me to the biggest impact that a content security policy may have at the content of your page. And that is, I mean, what's the common denominator of the things that do not work? What doesn't work is the color, possibly the size, and also the size of the placeholder down there. These are all inline styles. Now, by default, if you have a content security policy that applies to style sheets, so default SRC is set, or there's a specific directive for style sheets, guess once what it's called, style SRC. So if one of those is set, or both, then by default, inline styles are disabled. Why are they disabled? Because in legacy browsers, you could inject JavaScript code via style sheets. In modern browsers, there are some hypothetical proofs of concepts where you can send data from the page to somewhere else, a keylogger, for instance. I don't really believe in that, because if you have a content security policy, it just doesn't work. But there's a reason why this was made this way. So what does that mean? Well, if you have a modern application, of course, you don't have any inline styles at all. You have your styles in external CSS files anyway. But for older applications, you may need to refactor that. The other option, or the other problem here is that the JavaScript code we are using is also of a very, very specific kind. What the JavaScript code here does is we are calling set interval, which isn't a problem, right? So this runs code every n milliseconds, and n is 1,000 here, so once a second. But we are providing the code as a string. In JavaScript, that counts as a call to eval, right? So set interval, set timeout with strings counts as this. Calling the eval function counts as this. Using new function counts as this. Providing a sorting function as a string counts as this. So there are different patterns. This is also disabled. So no inline styles, no eval or similar in JavaScript. And as a consequence of no inline styles, also no inline JavaScript. And I mean, let's look at the positive aspects first. If you have a content security policy, you can't, if you have a cross-site scripting vulnerability, an attacker can't inject script src, http, other server.com, well, they could, but the browser won't load that resource. So that cross-site scripting vector closed, it's gone. If someone injects script, alert 1, yeah, they can inject it, but the code won't run because it's inline code. So cross-site scripting, solved. Thanks to browser support, not thanks to our brilliance in making our application cross-site scripting foolproof. No, the browser helped us here. But of course, again, legacy applications, what do you do? And I think just to show you what would need to be done, let's have a look at the values we can use for those -src directives. We can set it to star, well, okay. An origin, a URI, self, we've seen that, and none. So good news, if you do script src, that's the directive for JavaScript code, none, then you won't have any cross-site scripting issues. You also won't have any running JavaScript code in your application, so this might be a downside depending on your application, but still. But of course, there are some better things. Now, how do you enable inline? I mean, enabling inline JavaScript code means enabling cross-site scripting vulnerabilities that are present. So don't do that at all. Enabling inline styles, you know, some frameworks need that. And at least in my usual thread modeling, that's not that big an issue, so I accept it. Well, it's not called enable inline because that sounds so positive. You have to think about what you're doing, so the value has to be a prohibitive name so that people think twice before implementing that. So that's why it's called unsafe inline, right? So you have to type unsafe before you're re-enabling inline styles. Don't do this for JavaScript, just do this for style sheets, and only if we absolutely must. Well, and then unsafe eval to re-enable eval. So we could try this out real quick. We have the time. So let's go back to the content security policy, and then for style sheets, I enable self again because I might have some CSS file, and unsafe -inline because I can. And for JavaScript, I also allow self, and then unsafe eval. Now you may wonder, wait, can't you just refactor your code? Yeah, I might, but well, we'll have a look at that. So let's load it again. And so now you see, okay, we still have that graphic again. The styling works, everything, but we still got issues with the call to that endpoint and the display of the time. And there are several aspects to that. And there's one problem. And that problem is something you have to have on your horizon. There are several issues in here, right? So we don't have time to discuss them all and fix everything. But I have a third-party dependency here. Don't get me wrong. I'm not kind of, complaining about that specific templating engine. It's perfectly fine. But just imagine the templating engine would be used all over the place in your very complex application. That templating engine is using new function internally. So it is using eval. Now here in my application, I just could yank that out and do my own templating. But if you can't, in that case, you really have to enable eval again, and then you have to really triple check whether all calls to eval and similar, whether they only get trusted data as a parameter. Here in my application, that would work because I have an endpoint. That endpoint is under my control. The endpoint returns the current time, so that's digits and the colon. So that would work. In a more complex application, it's just much more difficult. And you just have to be aware of what your application is doing. That's super important. Where stuff is loaded from, and if those dependencies do things that are not recommended any longer, right? So that really is, in a nutshell, how content security policy kind of affects an application. I mentioned it affects it in a good way, because if there's a cross-description vulnerability, it's hard to exploit. Depends on how everything is set up. But by all means, try to implement it. But for a legacy application, there might be more work. And I mean, the elephant in the room is, what if the legacy application has a lot of inline content, especially inline JavaScript? We have a lot of .NET content, obviously, at this conference. So some older people in the room may have worked with ASP.NET Web Forms. ASP.NET Web Forms, yeah, love for ASP.NET Web Forms. ASP.NET Web Forms, what they did is they always output a specific block of JavaScript code, the __ do postback JavaScript functions. Yeah, I see a few people nodding. So you've been through this pain as well. That's inline code. But you can't just do unsafe inline for JavaScript code. But how do you make this code running? Because that code was paramount for ASP.NET Web Forms to work if you had a form on the page. There are two options. One option is you create a secret, a number used once. And then in the content security policy, you just use nonce, number used once, dash, or hyphen, and then that random string. Of course, it should be more random and longer than ABC123, but I only have that much space on the slide. You put that in content security policy and instruct the browser essentially, okay, wherever there is nonce equals ABC123, that code is allowed to run, that inline code. Right? So you can do that if you control the script tag. ASP.NET Web Forms, to stay with that example, you don't control that specific script tag, but there's a second option, and that would work for ASP.NET Web Forms and, of course, in other scenarios. If you don't control the script tag, but you know exactly what the code will look like, because that __ do postback method was predictable, you just calculate the hash of the content of that script tag. And then you put the hash in the content security policy, something like this. So you basically allow a specific piece of code to run. You can use SHA-256, 384, and 512. So a at least as of now, a collision with other valid JavaScript code is, the probability is basically 0. So you green light specific code only. And I think that is a great outing for legacy applications, where you can prevent at least some kind of refactoring. And talk about before we finish off content security policy, but it's such a complex thing and so valuable. So that's why I spent quite an amount of time on that. Especially for legacy applications, slapping on a content security policy afterwards is a good thing from a security perspective, but maybe not such a good thing from a UX perspective, because you don't know whether you messed up, whether you forgot something, and then on the production system somehow something does not work because the content security policy makes the browser not load a resource or not run specific code. So you want to know if that happens. And for that, there's a reporting infrastructure. There's a directive called Report URI in Content Security Policy 3 that was renamed to Report 2. But remember, if you only develop for Chrome, feel free to use that. But no, we are using Report URI so far. And that Report URI directive as a value just gets a URI. And whenever there's a policy violation, so a resource can't be loaded thanks to content security policy, or code won't run thanks to content security policy, that URI receives an HTTP post request with information about that failed code or failed resource load as the payload, right? So you get an API call when something goes wrong. And I mean, what are the only 2 reasons? I can't come up with more. 2 reasons for a policy violation. Reason number 1, you forgot something, right? That tracking provider server that the marketing team implemented last week. And what's the second reason for a policy violation? You have a cross-site scripting vulnerability and someone tries to exploit it. These are 2 things you want to know. So, yeah. By all means, use the reporting directive. And there's a second header. It's called Content Security Policy Report Only. And it does exactly what the name suggests. It reports a policy violation to that endpoint you set up, but it doesn't enforce the content security policy. So your application runs as if there was no content security policy. So if you slap a content security policy on an existing application on the production server, use content security policy report only at first, and then, let your customers use the application for a couple of weeks, and then check whether there are any policy violations. If there are, fix the policy or fix the code. And if there are no more violations, enforce the content security policy. So this works a great deal. There is one kind of outlier here, and that is single-page applications. Because in single-page applications, a common trend is that everything runs in the browser. So you load the SPA framework. The SPA framework then comes from self. So the content security policy doesn't protect you there. And then for some reason, there is DOM-based cross-site scripting. So the logic takes data from, I don't know, maybe from the URL, the hash, I don't know. Applies it to the page, boom, you have cross-site scripting. So what do you do against that? And there is something that eventually will help us here. For single-page applications, the basic sink for cross-site scripting attacks is if data is written to inner HTML. There are other options as well, but the inner HTML property is basically where most of the attacks happen. You have some payload. That payload is written into the DOM, is interpreted as HTML, and could be JavaScript code, right? Now, there is something called the Trusted Types API. Bad news first. If you look at the standard, the people leading that effort, they all work for one company. The standard is not done yet, so what does that mean? Chrome, Edge, Opera, they support this. Other browsers don't yet. Still, apply it, because those other browsers will just ignore that feature. And it looks like this. We use a content security policy again, and there is a new directive called Require Trusted Types 4. There's only one valid value, and that one valid value is script. So essentially, what that does is you can't write strings to the inner HTML property. It just won't work. So actually, I think I have an example here. So let's just say I have here some text, and I'd like to write this to inner HTML. So that worked. Essentially, what this means that I could try cross-site scripting here. So how about image src equals NDC on error equals alert 1, right? So you know, script kiddie cross-site scripting. And writing that to inner HTML means, oh, we had cross-site scripting here. Now, if you go to the source code here, and forgive me for just preparing this, so we do save some time. If I add this content security policy header, this I can also use via meter tag, which was faster here, and reload this. And if I try to write something to inner HTML now, it worked here when I output the text, but here when we have the rendered code, it did not work. Why? Because in the console, and I hope you can see that, it said, failed to set the inner HTML property. This document requires trusted HTML assignment. Yeah, because thanks to activating that trusted type mode, I cannot write strings to inner HTML. I can only write trusted strings to inner HTML. And yes, of course, you could create a loop and then convert every string into a trusted string, but at least, you know, this makes you think, should I really write verbatim strings into inner HTML? And a typical pattern, which you could then use, would be this. So you could use the very, very excellent DOM Purify library, which has a sanitize method. So you take some input and it just turns this into harmless HTML. And you can configure it so that instead of returning a harmless HTML string, it returns a harmless trusted HTML string, right? And so if you do this, so this would be the button on the right. So let's just try image src equals NDC again. On error equals alert of 2, maybe this time. And now you see that DOM Purify kind of sanitized the input, so it got rid of the JavaScript, the event handler. And then this was indeed written to inner HTML. I mean, I have no image here called NDC, but you see that the browser now tried to render an image, okay? And Chromium-based browsers only at the moment, but for single-page applications, this can also be a game changer to really get cross-site scripting under control. So I encourage you to take a specific look at that and consider implementing it in your applications. There is another aspect, and that was kind of embedded into the example here, but I didn't point it out, and that's sub-resource integrity, another browser security feature. So if you load JavaScript from a CDN, or if you have a CD/CI infrastructure and want to make sure that no one injects in that infrastructure injects some alien code as part of the process. You can set the integrity attribute when loading resources like JavaScript to a hash of the expected content. Especially if you pull JavaScript from a CDN. If someone takes over this CDN, they might be able to inject arbitrary code into your page unless you tell them not to. And you could see that right here. So I'm having two dependencies here, Bootstrap for the layout, quote unquote, and the DOM Purify library. And you see that I just provide the SHA-512 hash for DOM Purify and the SHA-384 hash for Bootstrap. And so if something would change on that server I'm pulling that from, that integrity value, that hash, would not match the actual content of the page, so things would not load. Super simple, but super effective. And of course, it's even better if you don't load anything from a third-party CDN, because then you have a single point of failure there. But if you do, at least with that, you can make sure that you get the content you are actually expecting. The next threat I'd like to discuss is cookie hijacking. If you read on the web, often it's Medium articles about threats, especially about cross-site scripting threats. Everyone says, yeah, with cross-site scripting, you can steal cookies. Now I have good news and bad news in the same sentence. If you have cross-site scripting, cookie hijacking ain't a problem these days. It just isn't, because cookies can be secured. The bad news is, if you have cross-site scripting, you still have problems, lots of problems. But cookie hijacking isn't it. So cookies cannot really be stolen. I mean, we have to protect our cookies because often they contain sensitive information, such as a session ID. So we need to protect them. And there are ways to do that. The original cookie specification that Netscape put up in 1994, I believe, here's an archived version, looked like this. So this was taken verbatim from the spec. So we have set cookie as the HTTP header to set a cookie, couple of metadata, and the last one is the secure flag. Even then they thought about, maybe we don't want cookies to be stolen, at least at transport. So we can save them or secure them at transport by using the secure flag. Secure flag says this cookie can only be sent back and forth if a secure transport mechanism is used, so that means HTTPS for our web applications. So if you have a cookie, a session cookie, and then someone goes to http://ndcoslo.com, that cookie will not be sent because it's not HTTPS. So cookie theft can be prevented like this. So we can secure cookies at transport. Can we also secure cookies at rest? Because we have cross-site scripting, right? And if you have cross-site scripting, we can, I don't know, we can inject some JavaScript code, and the JavaScript code then might access document.cookie. And we see, oh, wait, there are 0 cookies, but I'm pretty sure that the application is using cookies. Well, because there's another thing, originated in IE8, but now works in all browsers. It's the HTTP-only flag for cookies. HTTP-only protects cookies from JavaScript seeing them. And I mean, in most, if not all cases, there are 0 reasons why JavaScript should be able to access cookies, because that's an HTTP feature that the browser kind of manages together with the server, and therefore JavaScript does not need to see this. Just by applying that HTTP-only flag, JavaScript doesn't see that cookie. There are proofs of concept that JavaScript can somehow get access to that cookie if the trace HTTP method is activated at the server, but chances are it isn't, right? So that is pretty nice. And modern browsers also support a relatively new feature, cookie prefixes. If the name of a cookie starts with __host, then it's impossible to inject a cookie that sets the domain flag of that cookie, which is also a nice attack so that the cookie could then be sent somewhere else. If the name of the cookie is prefixed with __secure, then that cookie needs to have the secure flag. If it doesn't, it's rejected, right? So by setting those 2 flags, by applying the secure header and by applying as the secure flag and by applying the HTTP only flag, your cookies have a solid security posture, right? And that's why cookie theft is not a problem. The actual problem these days is if single-page applications do authentication and they have a token, and the token is stored in local storage. Local storage is a JavaScript API. So if you have cross-site scripting, that value is gone. That can't be protected like this. Still, with a content security policy, you might make it super hard to send the token to somewhere else, but still, right? So even for single-page applications, don't use local storage for your tokens. Use the BFF pattern, for instance. Now, we've seen that we can secure cookies by restricting them to secure connections. Is there a way to force the browser to use secure connections all over the place? There are a couple of options. The arguably best option so far is called HTTP strict transport security. It's an IETF standard this time and manifests in an HTTP header called strict-transport-security, which the server sends as a HTTP header and instructs the browser, next time you are talking to me, right? It's like bad parenting. Next time you're talking to me, use HTTPS. And browsers comply. You have to set a couple of options. So for how long shall the browser comply? Half a year, 2 years. And should this also apply to all subdomains? Both are good options, I would say. And if that is set, and a user then say if ndcoslo.com would set that, and a user tries to go to http://ndcoslo.com, the browser would automatically make an HTTPS request instead. So if you do this, only the very, very first HTTP request could be plain HTTP, unsecured. All future requests will be HTTPS. You don't want to do this maybe on your local dev system because, localhost certificates, yada, yada, yada. But on all publicly available servers, that's what you want to use. Also, web browsers these days have a built-in security mechanism in terms as there is a list of domains for which strict transport security is enabled by default. And here on that website, you can add your own domain to that list. So with the next browser update, strict transport security is already on. So even the very, very first HTTP request is a secured one. So just type in ndcoslo.com, for instance, and they say, yeah, please add me. Well, turns out something didn't work when going to ndcoslo.com, so I know it wasn't me. But some prerequisites have been met, and I tried this before, of course. So, and there's one prerequisite NDC also did not meet, maybe intentionally. But if you meet those prerequisites, you can set your own site on that list, and then it's HTTPS forever, which, if you ask me, is a fantastic thing. Yeah. Oh, did I misspell? NDC, also.com, yeah. Why didn't they get that domain? I mean, seriously, cyber squatters. Oh, I have to tell them. Thank you very much. Yeah. So one of the prerequisites is missing. You have to provide a directive in the header. Yes, I want on that preload list, and they didn't do that, or didn't want it. Right? Not a problem, but yeah. That is the reason. Thanks again. Another attack where people tell me, no one, that's not happening anymore. It's cross-site request forgery. But again, looking at cvdetails.com, you see that chart goes here till 1500. For cross-site scripting was 6,000, so right, factor of 4. But still, double the number here, and you'll see we will get a new record here this year. So cross-site request forgery is often going like this. An attacker prompts your browser to send an HTTP request to an application. You're already logged into that application, have a session cookie, and the attacker redirects you basically there. And on that request to that other website, all your cookies of that website, of that application, including the one with the session ID, are automatically sent. That's how cookies work. A little bit simplified, doing a request to ndcoslo.com sends all the ndcoslo.com cookies alongside that request, right? And so cross-site request forgery is a dangerous thing. The situation got a little bit better. Yes, I know the numbers don't show that, but all of the frameworks, including ASP.NET Core, they have built-in cross-site request forgery protection. Now, even with ASP.NET Core 8, even for minimal APIs, there's an anti-cross-site request forgery middleware. And you can, prevent this with the use of one-time use-only tokens in the forms, etc., etc. But still, web browser teams decided we need to do something against this. And what they came up with is something with a weird name. So apologies for that. It's called same-site cookies. Yeah, it is called same-site cookies, but I would prefer that they called the API, so to speak, we need to use cross-site and not same-site. Let me explain. There is a new flag, well, relative new flag now, for cookies. It's called same-site. And the same-site flag dictates the cross-site behavior of those cookies. Confusing, yeah, I know. So, what is a cross-site request? In my browser, I'm on a.com, maybe like attacker. And from there, I'm sending a request to b.com by being redirected, by submitting a form, clicking on the link, whatever. In the old days, well, for the last 30 years, essentially, that request to b.com would send all b.com cookies, hypothetically allowing cross-site request forgery. Now, with the same site flag, you can restrict that. So when there's a cross-site request, A.com in the browser, request to B.com. Then there are three options. I'll start with the last one, none. None means not that the cookie is not sent. No, that's why it's so confusing. None means no protection. So the cookie is sent, just like in 1994. Lax means, for that cross-site request, yeah, cookies are sent, but only if it's a request that, according to the REST principle, doesn't change the state of the application. Get, head, like Google search result page going to your site. Yeah, if there's already a session open, you may want to recognize the user, so that works. It's a GET request. But for post, put, delete, patch, for those, the cookie is not sent. So if you have cross-site request forgery, it may not be exploitable because on that forged request, if it's a post request, which is often the case, there's no cookie sent alongside if the same site level has been set to lax. Strict is even better. Strict means if there's a cross-site request, the cookie is just not sent. The cookie is just not sent, even for a GET request. And that can be a good defense in depth strategy against cross-site request forgery. So no excuse for not having this one-time token in your forms, etc., but defense in depth. Like content security policy is defense in depth. There's one catch, though. And that catch is, it's called same site. It's not same origin. So what is same site? Same site is, I think, ETLD plus one. So it would be ndcoslo.com or, I don't know, google.co.uk. So www.ndcoslo.com, api.ndcoslo.com, and publicbeta.ndcoslo.com, they would all be the same site. So if you have a cross-site scripting vulnerability on beta.ndcoslo.com, that code could send an HTTP request to api.ndcoslo.com, and since this is considered same site, cookies would be sent alongside that request if no matter of the same site setting, right? So make sure you have solid cross-site scripting protection on the whole site, even on those forgotten legacy systems. One more reason to, precisely know your assets, the assets you're using. There is another attack, and that is harder to pull off, and that's why I think it's super dangerous. And that is clickjacking. So clickjacking essentially means I have a page with a button, and I want the user to click on that button. So it could be in an internal system, the user can delete something. I can't, but my victim can. So I lure the user to a site or a web page where the application with the button is in an iframe. I make this invisible using CSS, but the iframe is there. And then if the user clicks on the page, the user actually clicks on the button in the iframe and carrying out that action. Right? I have an example here, but for the sake of time, let's not look into that. I think the description is good enough here. So the problem is that our application can be loaded in an iframe on another site. Right? That is a problem, but once again, browsers come to our rescue. I mean, we could write JavaScript code and find out are we in a frame or not, but let's just the browser do it. Once again, IE8 introduced something, the X frame options HTTP header, which basically says, so this page must not be loaded into an iframe or in a frame if it is set to deny. That means absolutely don't load it in iframe. You can also say same origin, yeah, load it in iframe, but only if the page with the iframe has the same origin as the page in the iframe. That's of course a little bit limiting. So on ndcoslo.com, you would not be able to load something from widget.ndcoslo.com in an iframe. If you need more flexibility, ditch that header, because we have a content security policy now anyway, right? Everyone will have one after this talk. And so just set the frame ancestors directive, where you can basically provide a list of origins that may be loaded in that iframe. All right, there are a few more, and what I'd like to discover next is data leakage via referrer. So there is this HTTP header, referrer, written with one R because there was a typo in the HTTP 0.9 specification, and we are always backwards compatible, right? So that's why that header is always misspelled. But yeah, right typo, right would be refer with double R. And referrer policy is a W3C almost, well, it's a bit difficult. It is a candidate recommendation, so one step before a standard since 2017, but there's also an editor's draft that was updated last December. So they're still discussing which features which browser wants to implement or not. So a lot of politics going on. But the idea is like this. The server sends an HTTP header, referrer-policy, and then basically says, this referrer header, which contains the current URL. So if you click on a link on a.com to b.com, the referrer header would contain the a.com URL and send it to b.com. So if you have a secret intranet and have links to arbitrary websites in there, the URL of your secret intranet might leak by clicking on those links thanks to the referrer header. So you can basically say things like, yeah, just set the referrer header if the target is the same origin as where we are currently at, right? And there are several other options. Not all of them are supported in all browsers, but things like origin or, my favorite, no referrer. I don't need the referrer. The marketing team sometimes needs the referrer to calculate the path through our application. So maybe something like same origin would work. And origin just sends the origin, but not the full path. So you can really kind of narrow down what is being sent if something is sent at all. And as many of those things we discussed, I think it's very colloquial what I'm saying, but I think, how does the saying go? A lot of bang for the buck, right? So often very little effort. You add a header, relatively trivial to implement, probably no side effects, but the security posture of your application just immediately got better with just, half an hour of work. And refer policy, one of those. There are some other headers where you could debate how much gain you get from them, but still I'd like to mention a few of them. So there was something called feature policy, which was an HTTP header which could restrict which APIs the JavaScript code in an application was allowed to use. So whether, for instance, geolocation could be used, or camera access, or USB access, stuff like that. If you have a big application, but you can't control all of the content in the application, this might be an option. This was now deprecated, so I think Firefox still supports select parts of that. And the successor is called permissions, plural, policy, where the syntax looks a little bit different, but Chromium browsers only at the moment. So it's nice to have, but it doesn't protect everything. And so I think in the end, the goal is that eventually there will be something called a document policy, but it will take some time until the web browser teams have decided upon which route to go. So again, lots of politics, a little bit of stalling. So while this helps, it doesn't help all of your users unless you just say, Chrome is the way to go, but I urge you not to do that for a variety of reasons. I've seen Netscape versus IE, I've seen Firefox versus IE. I don't want to see that again, but I'm seeing it. There are a couple of other four-letter acronyms that manifest in HTTP headers. And they start with cross-origin. There are more than those three, but just let's quickly look at those three because I think they sum up nicely what is possible. So cross-origin embedder policy basically says, okay, if I have content on my site and I'm embedding something, or if I have content on my site and that is embedded on another site. I mean, you have seen an example before. I was stealing the Oslo Spectrum logo and included it on my web application. They could have prevented that by saying, no, you cannot directly include something from that website. So you can set a policy. And in that policy, you can basically say either, okay, everything is good, or you need something called CORP, that's the cross-origin resource policy. So another HTTP that has to be set for the resource you're using. And what the cross-origin embedder policy also supports is reporting. You've seen the report URI directive when talking about content security policy. Well, this is using this new report to directive and a little bit different syntax. But essentially, if something goes wrong, so if someone tries to include your content, then you may be informed thanks to that reporting infrastructure. You can also have a cross-origin opener policy. So the idea is if A.com opens B.com in a pop-up, there is pop-up could also mean new tab, right? Then the open page might to some degree access the opening page, which was an attack that once hit Instagram. Therefore you could restrict that as well and say, okay, if the open page has a different origin, no connection there whatsoever, which I think is useful. And as I already mentioned, the cross-origin resource policy. So if something can be included as a resource or not. I'd like to discuss one more HTTP header that is kind of security related. I find it useful, but maybe that's my developer heart, or because I'm old. That's clear-site-data. I mean, you know, I have this love-hate relationship with caching. Caching on the server when the server controls it is great. Browser caching is cumbersome. Do you all have this disable browser cache checkbox in the F12 developer tools on? Yeah, I do that as well, but of course the end users don't do that. But with the clear-site-data header, you can, if the server sends that, you can basically instruct the browser to purge certain data from that site, which is great because that really disables some kind of caching. There is good browser support, well, uniform browser support for cookies and storage, local storage, session storage. Chrome itself supports a few more options, and Chromium-based browsers. But basically for cookies and for storage, that's pretty neat and pretty comfortable to use that if you're in the situation that you have to absolutely make sure that data is not cached or data is purged from cache. Yes, and I know we have various caching HTTP headers. We can use tricks like appending random stuff to the URI. All good, all good. But with clear-site data, this can be made explicit. Well, and finally, there is this whole topic of authentication. I mean, this would be good for a talk of its own, so you can easily fill over an hour with that. I just want to mention that because it's basically up and coming. So we have the WebAuth specification. I mean, you may have seen this, right, that if you have a YubiKey dongle, right, you can plug it into your machine, then tap on it, and then you can log in against applications. Sometimes applications aggressively try to want you to use that as well. And an upcoming standard, and lots of applications are nagging you at the moment to do this, is to use passkeys as a kind of a digital credential in lieu of passwords. So people would like to get rid of passwords, which, don't get me wrong, is totally fine. I mean, I still have my reservations, but again, this would be a talk for a different day and time. If you're interested in that, there's a very interesting discussion here. What about passkeys is good, but what the current implementation is basically lacking, and what kind of inherent risk we have, especially when trusting one entity with all of your passkeys. So this just as an inspiration for let's say further reading. And with that, I think we've gone through a lot of content. I think you have a lot of things to look at, things to do, things to read, and there will be more during all of the remaining 3 days of the conference. So enjoy your time here, enjoy the conference. I'm here for any questions, and with that, thanks for your kind attention, and have a wonderful day here at NDC Oslo. Thank you very much. Great to be back. Thank you.
Oh, it's time. I'm really excited. This is the part where I tell you I am definitely going to post the slides on my site tonight. Except for in this talk, there are no slides. But the cool part is the code that we're going to build today is already online at github.com/robrich. Level up DevOps, GitHub Actions, and Kubernetes. Here it is. Yeah. If you want to grab an easier URL to get there, let's head over to robrich.org, robrich.org. We'll click on Presentations here at the top, and here's Level Up Your DevOps with GitHub Actions and Kubernetes, and the link to the GitHub repository is right there. While we're here on robrich.org, let's take a look at the About Me page, and we'll see some of the things that I've done recently. Both Microsoft and Docker have given me some awards, Redgate as well, and Cypress. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Oslo or wherever you traveled from, find me here at the event or hit me up on any of the socials, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I've written a few books, well, some chapters in books. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into Level Up Your DevOps with GitHub Actions and Kubernetes. I understand that in about 20 minutes, we're going to get a national test of the broadcast system, and all our phones are going to beep at maximum volume. This will be really entertaining. Hopefully the build is going by then. So we'll see. If you want to turn off your phones, from what I understand, even muting them won't actually stop the beeping. So yeah, my phone too. This will be entertaining. Here's a repository. It's pretty much empty. I did come in here and create some secrets here. So I come into secrets, and I created some secrets here just to be able to use over the course of our build. But otherwise, it's a pretty empty repository. Let's build up a website. We'll put it inside of a container. We'll deploy it through a DevOps pipeline and start it in Kubernetes. So here's that folder. I've got nothing in Kubernetes. I've got nothing in this directory. And let's start by scaffolding out a website. Now, we could scaffold out a website in anything, but .NET's kind of fun. So let's say .NET new. I'm going to do an MVC site. I'll say name is Level Up DevOps. Thank you, GitHub Copilot. It knows where I'm going here. Output into the current folder. Now, both name and output are optional parameters. If I didn't put in those parameters, it would use my folder name and create a new folder inside of it. So I would have a demo folder and a second demo folder inside the demo folder with my site there. But I just scaffolded it right here. So we've got that there. Let's open it up in VS Code, and we'll take a look at it. Excellent. So we've got this full site. We've got controllers. Here's our home controller. We've got views. Here's our home view. And it says, welcome. Let's say welcome to NDC Oslo. Excellent. So now that we've got our website built, let's see if we can put it inside of a Git repository. So I'm going to create a .gitignore file, .gitignore. And let's start talking about the things that we need in our gitignore file. This is everything that we don't want to commit to our repository because it'll change frequently, or we could download it again. It will just create cruft in our repository. There's 5 groups of things here. Downloaded content, built content, temp files, user files, and secrets. Cool. Those are the 5 things that I don't want to commit to my repository. So let's take a look at each group and make sure that we've ignored the things that we need to. Downloaded content. Well, if I'm in a .NET Framework project, I would have the packages folder. If I'm in a Node project, I have the Node modules folder. In .NET Core, well, we have neither of those, so I'll just leave that section blank. Cool. Next up, built content. Well, I have the bin and obj folders here. Those are both built content. I don't want to commit those to source control. Temp files. Well, actually, let me move temp files down here. Let's talk about user-specific files. I have the .vs folder, star.suo, star.user. These are all files generated specifically for my environment that starts talking about my use of Visual Studio or VS Code, and I don't want to commit those. If I'm using another IDE, I might want to ignore, for example, the .idea folder. Maybe I want to ignore the .vs code folder. Depends on what conventions we use there. Now, all these are user-specific files, so I don't want to inflict my preferences on you or your preferences on me. If I move things around or happen to change different settings in my IDE, that isn't necessarily a thing that you may want to accept. Next up, temp files. So star.log, star.tmp, star.back. Yeah, definitely don't want to commit those SQL database backups. Star.orig, that's where we have merge files from Git. Any of these sorts of temp files, if you get to a commit window and there's files that look like they're really odd, you might want to add to this list. And then next up, secrets. Now, I might have a .env file, so I'll add that here. But let's actually look at where we would put secrets. So I have this appsettings.json file, and I'll probably put my connection strings in here. So let's put in connection strings, and we'll do my DB. And let's create the server, and we would put in our secret there. But let's not put secrets there. Let's instead use environment variables in production. Use envar. And that's my queue so that when I start up the website and it fails and it says, I can't connect to use envar, it's like, oh, let me go check in the environment variables. Okay, so that's the one that I'll use in production. In development, I'll probably want to put my local connection string right here. So I'll start doing the server game again. And again, that's a secret. Let's not do that. Let's say use user secrets. And I love that user secrets is built into ASP.NET Core so that we can just grab the things. Now I have an extension here. I have the .NET user secrets extension, which allows me to come in here to my CS proj, and I'll say manage user secrets. Now the first time it's going to say, hey, you don't have a setting in your CS proj file, so it just added it for me right here. Now it just needs to be a unique string. By default, it creates a GUID, and that's interesting, but not super discoverable. So I'm going to change that to level up DevOps. And now if I manage user secrets again, you can see that, well, last time I did this demo, I set the connection string. This file you can see is in my local app data roaming folder. It's in my user profile, so it'll definitely not end up in source control. So excellent. We were able to move our settings outside of appsettings.development.json, appsettings.json. And so here in our git ignore, we probably don't need to ignore those app settings things. It doesn't have secrets in it. Now we do want to double check and make sure as we're committing things that we don't accidentally commit our secrets there, but I think we're good. Cool, so we've got our git ignore file. Let's close others. Next up, we want to get this into a container. Let's build up the Docker file and .docker ignore that we'll need to be able to get this in place. So I'm going to start with the .docker ignore. And this Docker ignore file has nearly the same syntax as a git ignore file. So I'm actually just going to grab that git ignore file and set it into place. Now I say nearly the same because in a .docker ignore, it assumes that it's relative to the beginning of the repository, where in a git ignore, it's in any directory. So if I have nested folders, I might want to say, well, in any folder, the bin and obj folders. Now I'm just going to do that for those two, but we might want to run around to all of them. Maybe that one needs to go in folders. Maybe these ones need to go in folders. And so we can walk through all of these places, ensuring that we've got the the settings set just so. Now we've got those 5 places: downloaded files, built files, temp files, user-specific files, and secrets. Inside of a Docker ignore file, there's a 6th setting, and it is non-production files. So let's add that. Non-production files. Now in this section, we'll do app settings.development.json. GitHub Copilot knows where I'm going there. And we'll also add here this launch settings.json. This is all of the settings that we would use locally to start it up inside IIS or from the command line, and we definitely don't want that inside of our container. So that one is in a folder. We'll say launch settings.json, and now we're ignoring that file too. These are all the things that we don't want to copy into our production container. Now the cool part here is that will ensure that we have a clean, unique environment to be able to build this. One of the principles of DevOps is that we always build in this neutral environment, and a Docker container will be exactly that. We've excluded everything that might be user-specific or temporary or not production so that we can have this clean environment every time.
You have a spelling error.
I have a spelling error. Where?
21.
Yes, I do. Thank you. It is not lunch settings, it is launch settings. Better? Thank you, that was awesome.
Thank Copilot for giving you the spelling error.
Thank you, Copilot, for giving me that spelling error. I love it. Docker file. The next one we want to build is the Docker file. Now, it's important that this is Dockerfile and not dockerfile.txt. So if your editor created it as dockerfile.txt, easy enough to rename it and just make it Dockerfile. Yeah, file without an extension. Windows loves that part. Now, I do have the Docker extension installed, and so because of that, I get these nice icons, I get some autocomplete help, and that's pretty cool. So there's 4 main verbs here in a Docker file. There's from, copy, run, and cmd. And if you understand these 4 main verbs, you can read and write most Docker files pretty much in their entirety. And that's really cool. We'll see a few more today. But these 4 verbs are the things that do that Docker content. So let's start with from. We want to stand on the shoulders of giants. We want to start with a base image that has the tools that we need, but not too many. So let's head off to Docker Hub, and we'll search for .NET. And we'll land here on this repository that is a meta repository of all the other .NET repositories. Now, .NET samples is great. Lots of different Docker files that we can use for examples to pull from. Monitor is fun, monitoring a .NET app. Runtime deps is everything that we would need to install .NET, but .NET isn't installed yet. Built on top of that is the runtime. It allows us to run console apps, but not web servers. Built on top of that is ASP.NET that allows us to run web servers, but doesn't have the build tools installed. And then SDK is the one with the build tools. Well, we want to build, so let's start there. Let's open up this one and take a look at the base image. Here's that base image. And I'm using .NET 8, so I'll pull that one. Scrolling down, we can see various tags. And there's one, if we just use .NET 8, we're building on top of Debian, but Alpine is significantly smaller. So let's use 8.0-Alpine, and that'll give us a smaller base image. So from this -Alpine, and we now have all of the build tools in our base image so that we can start to compile our ASP.NET application. Excellent. Let's copy everything from the directory where we'll run our Docker build command into the current directory in our image. What is that current directory? Let's set workdir to /src. Now that could be anything. I could say var lib foo bar, and it will recursively create and change into those directories to be able to build there. But in this case, src is completely fine. That's descriptive enough for me. I'm copying everything into place. Now that I've copied everything into the place, now let's run some build commands. If I was in shell, maybe I'm in bash, or maybe I'm in PowerShell, then what are the commands that I would run? Well, let's do a .NET restore, and I'll do demo.sln. I have the new C# dev kit extension, so it automatically generated for me demo.sln. That's pretty cool. .NET build. I'll build in release mode. Demo.sln. New in .NET 8. It now builds in release mode by default if it notices it's in a container. That's pretty cool. But I'll be explicit here. .NET test. I'm also going to test in release mode just to make sure that I don't end up with one debug build and one release build when I go to try and publish it. And then finally, .NET publish. I'll publish in release mode. I'll go to the app folder, and I'm going to do level up devops.cs proj. That's the project that I want to publish. Cool. So those would be all the commands that I would run from the command line if I was going to do this in shell script. And so maybe I might want to move this to build.sh and just call it, but I kind of like it right here. So now how do we run these as Docker commands? Well, let's do this. Let's run this one. Let's run this one. And this one. And this one. And now they are Docker commands. Cool. So to be able to get this built container, I need to run my tests correctly. I also need to build correctly. So if I have a build error, then my build will stop here and I won't get farther. If my tests fail, I'll stop here and I won't get farther. And that's really cool because now I know if I have a published image, I know that my build succeeded, I know all my tests passed. Next, let's set some environment variables like ASP.NET Core URLs. We'll go to port 8080 in this case. The plus means all IP addresses, so not just the loopback IP address, but I want to grab the public address as well. Let's do ASP.NET Core environment equals production. That looks great. And let's expose port 8080. Now that doesn't actually expose it, it's just metadata on my image that says, if you start, you probably want to forward traffic in on this port. Great, so I've got all of these in place. I probably also want to say env connection string __ my DB, and I'm going to set that to blank because I want the people consuming my app to set this environment variable so that they can then connect to the database successfully. Excellent. Now, CMD is that last thing, and it's the only one that runs at runtime. All the rest of these commands ran at build time, and so by the time I've finished my build, by the time I've pushed my image up to Docker Hub or another registry, then all of that part is done. But as I pull it down and I start it as a container, what do I want to do? I want to start .NET level up devops.dll, and I'm going to set work dir to /app to ensure that I'm now in the correct directory. Excellent. We've got a Docker file. Now this Docker file would work great in production. We could use this today. But there are some best practices that we can leverage here. So let's add some best practices. Well, one of the things that we want to do is avoid build tools inside of our production image. If, for example, this container got popped and somebody uploaded their own source code, they could compile it, they could add that to my project, and now I'm starting to run their code. Let me see if I can remove the build tools from the production image. Now, I could definitely build outside the container and copy into it, but then I lose my neutral environment. We definitely want to keep a neutral environment here. So let's head back over to Docker Hub, and we'll find the ASP.NET runtime. So let's pop up in the ASP.NET runtime, and we will take a look at exactly that. And then we will have, there's that image that we want to grab. Scrolling down a bit, we can see that it definitely has an Alpine variant as well. And so the Alpine variant is the one that we'll use. Oh, welcome to exactly that time. So I want to split my Docker file in half now. I want to have one side that is my build server and one side that is my production runtime. So I'm going to say this is from this new base image dash alpine, and I've now split my build in half. I now have a multi-stage build. Now this stage at the top will be my build server image, and this one will be my production runtime server image. And I put server in air quotes here because it's not a server, it's a Docker container, but we can kind of pretend it's a build server, and so we'll do that. Here's my build server, here's my production runtime server. Cool, we just built two different images at the same time. That's cool. Now here, workdir is app, and we want to copy the files. Let's switch this over to the dist folder. We want to copy from the dist folder into the current folder. And so now we'll get those resources into place. Now the interesting thing here is that right now it's going to go look in this base, in this host folder for the dist folder. Probably ought to add that to my Docker ignore file. We definitely don't want the dist folder leaking into place. And so really I want to copy it from up here. Let's say copy dash dash from equals build. Now where is build? Let's call this one as build. Now I could call it as foo or as bar, but I don't know, I think build is much more descriptive. Let's call this as build. Nice. So this is the build stage, and we could also then rename the other stage, the as prod or as runtime or as foo, but we're not going to use that name, so I'll just leave that off. Cool. So now, here in this build stage, we'll have all of our source code. And at the very end of this stage, we will go copy the published assets into place in this new image that does not have the source code. Also does not have the build tools. Excellent. If you upload source code into my image and try to compile it, there is no compiler. There's one more best practice that we can do. Let's imagine that we pop open this CSS file or this JavaScript file and we start making changes. Well, that will invalidate the cache of this copy layer, and then it will run this layer, which will re-download all of the NuGet packages. I just changed a CSS file. Why do I have to re-download all the packages? Really what I want to do is I want to put this first, and then copy all the things, and then do the build, publish, and release. Excellent. Well, I still do need to know what I need to restore, so let's copy in the demo.sln into place and copy level up devops.csproj into place. And now I've got the manifest that I need to be able to enumerate my dependencies and download those dependencies into place. So I'll grab my dependencies, I'll .NET restore, cache that layer, and then copy in everything else, except for what I chose to ignore. And then I'll build, test, and publish. And then finally copy those published results into place in this really thin image that only includes that bundled and published content. It doesn't include my source code. Now, if I didn't do this and I just said, well, let me run rm-rf src, that's deleting the content out of this layer, but it still exists in this base layer, so my image is still going to be very large. So we've now separated this into two pieces to maintain that, that separation and ensure the production image is as small as possible. Excellent. So we now have a Docker file. Using our best practices, we don't have source code in our built image. Our built image only has the runtime. We're also leveraging caching to make our builds faster locally. Now let's add a README file. New file, read me.md. Ooh, they really like us. Here's some README content for our repository that'll help our users understand how to use our repository. Okay, now that we've done the Docker bits and the GitHub bits, the Git bits, let's do the Kubernetes bits. I'm going to create a new file, k8s.yaml, and let's build some Kubernetes content. Now, the first thing, I've got this this VS Code extension, the Kubernetes extension right here, and that allows me to use some snippets. It will pull in some interesting things straight away. So I can say, will you create a deployment, please? It knows that it's a YAML file, and so now I can just scaffold out that. Level up DevOps, perfect. I want replicas to be 1, that looks good. I also want to add another label. Let's say image is image name, image label. There we go. And here in the image, I'll also do that. I'll say ACR URL / level up DevOps image label. This will be a replacement expression that will change at build time to match the details associated with our application. What is the port? The port is 8080. That's what we chose to do here in our Docker file. 8080 is right there. And we also want to set our environment. And so let's say the name is connection strings _ mydb, and that matches our app settings where it says connection strings. I could do 2 colons, but environment variables don't like 2 colons, and so that'll set that. That nicely matches here in the Docker file where I've got that connection strings. Now, I probably want some server equals some server and the user and the password. I definitely don't want those secrets here, so I probably want to either do this, db user and db password, or even better, I want to move that secret into a Kubernetes secret and reference it from here instead. So I'll leave that as an exercise for the reader. Let's create a service. Kubernetes service, level up DevOps. I want the selector to be my app. Let's double check that that's the selector here. Yep. And the port is 8080. And the target port is also port 8080. And now I have my service. Let's create an ingress as well. Kubernetes ingress, level up DevOps. I'll set the app to level up DevOps there. My host will be level up DevOps.aks URL. And I'll forward that off to the level up DevOps service on port 8080. Cool. Now, one more thing that I want to do, I want to set my ingress class name to Nginx. Now I know that Nginx is my ingress controller, and it can be able to catch that and put the content into place. Excellent. So now we've got our Kubernetes YAML file. I'm just going to go double check it and make sure I didn't typo things. Let's grab this one, and we'll use Beyond Compare to go look at the one that I built last time and check for typos. Oh, I called it version last time. That's fine. Haha, I had a typo in that part too. That's cool. We'll come back to TLS if we have a moment. Cool. Excellent. So we've got our Kubernetes content. We've built our website. We've built the .gitignore file. We've built the .docker ignore file and Docker file to get it into a Docker container. We've built the Kubernetes content to be able to launch it in Kubernetes. And now let's commit it to our source code repository. Now I'm going to very specifically look at our git ignore file and see how we did. Do we have any downloaded content? Well, actually we do. We have a bunch of this Bootstrap content. Let's actually head over to CDN.js and see if we can reference those from the cloud instead. Let's look for Bootstrap, and we'll take a look at the Bootstrap. Oh, yep, let's use bootstrap.min.css. I'm going to copy that tag, and we'll come here into our view, into our shared layout view, and here in this Bootstrap reference, we'll just reference that as a CDN resource. Now I don't need it in my project anymore. Excellent. Let's also come down here at the bottom, and we'll do a similar lookup inside of CDN.js to be able to grab the two scripts. We've got Bootstrap and jQuery for some reason. Let's use those from a CDN. Here in our validate scripts partial, let's replace these with CDN resources as well. And so now I've got that. The other way to go here would be to create a package JSON and npm install them. At that point, then I have two dependencies. I'd need to modify my git ignore to do that. And we'd also need to modify our Docker file to be able to do the npm install. But now that we've got these outside of the repository, we can come back here into our www root, and all of these folders we no longer need anymore. We're loading those libraries from somewhere else. Excellent. So now that we've got that solved, let's come back here into our commit window. Do we have downloaded content? Nope. Very nice. Do we have built content? Nope. Excellent. User files? No. Temp files? Any secrets? Let's pop open our not launch settings, our app settings.json and app settings.development.json. Nope. No secrets there. Very nice. Let's stage all these changes. Level up DevOps. Is it okay if I don't call it initial commit? Okay, so we've got our website, and now let's git push origin main and push that up to GitHub. If you now come back to this GitHub repository and refresh it, you should now see the content. Great. Our repository isn't empty anymore. Now let's build up a DevOps pipeline to be able to get this into place. I'm going to come into GitHub Actions and forget to delete the practice runs. And let's take a look at GitHub Actions. Now the cool part here with GitHub Actions is we can pick from lots of different templates. Here's ones that it decided were relevant. Here's deployment things, security things, continuous integration, automation, pages. Or we can even start with a completely empty workflow, and it will get us going there. I'm going to go back here, and I'm going to choose a simple workflow. That'll get us started. Here's our simple workflow, and let's start configuring from there. Cool. So I'm going to do this. Docker build Kubernetes run. That's what my build will do. Let's clean up some of this. We want to do it on push to the main branch. That's great. We'll come back to pull requests. Let's remove that. Workflow dispatch is great. Have you ever done a thing where you want to kick off the build so you commit, well, a space in some random file? If you have workflow dispatch, you're able to, that's happy. You're able to kick off the build directly from inside GitHub. We'll see that in a minute. Now, what do I want it to do? Well, I would like it to do these steps. It'll run on Ubuntu. That's excellent. It starts out by checking out my content. And then I can choose to run one-line script or a multi-line script. I like that. Let's start with a multi-line script and build up all the steps that we need to do. Let's say docker build and push Kubernetes kubectl apply. Those will be the steps that we do. Excellent. So docker build, I'll tag this right away, level up DevOps, version, and in the current directory. Well, I want to tag it with my container registry. We did have that secret that we built previously, and so let's go take a look at that secret. Here's my secrets that I created. And so my container registry, I just happen to call this environment variable ACR URL. Well, how did we build those secrets? Let's come into using secrets inside of GitHub Actions. We start off by creating the secrets, go into settings, click on secrets. We will add a secret. We did that. And then when we use it in the code, we can use it like this. $curly secrets dot that secret name, and then that will reference our secret. So let's do that here too. I want to say, I want to reference my ACR URL, and that then will be the tag there. And here I'm going to tag it with github.sha, my Git hash. Now I could use any version, I could use the build number, but what I like about the GitHub SHA is it's going to be unique for this source code, and that will just create a natural mapping of if this is the image running in production, I can get back to the source code that created it. Cool. So we've got that Docker build. Let's say Docker push this image into our container registry of choice. Not there, there. And that will push it. Well, actually what it'll do right now is it will fail authentication. We need to log into Docker Hub, in this case, Azure Container Registry. So let's do a Docker login, and we'll take a look at, oh, here's a cool task. We can go view the marketplace listing, and we can see how this task works. We could take a look at the GitHub repository that builds this task. We can take a look at various use cases. And we can get a really cool setup here of how we might use this. That's great. Or the shortcut here. Here's the content of how we use it right here. I'll just copy that, and I'll set that into place right here. And unfortunately, we need to indent it very carefully because, well, YAML. There we go. Now we've got this Docker login in place, and let's set it in place. Now we've got this registry. We have, nope, not that one. We have this secret ACR URL, and that'll get us straight into that registry. If we were in Docker Hub, we wouldn't need that. What is our username? Well, let's put in the ACR username. And then we'll look at the password. We have a secret for that too, ACR password. Excellent. We'll leave ACR off, and then let's talk about logout. Now, if we're on a shared host, we probably want to remove our secrets after this use. And so let's definitely log out. Part of GitHub Actions, this hosted runner, is it's just going to destroy the whole VM after we're done. And so our secret will definitely be gone, but it's good code hygiene. If we're using a local runner or we have a corporate runner, then maybe this is more important. But let's do good code hygiene. We'll remove our secret. That doesn't remove it after this step runs, but rather after the entire build runs, it will clean out that secret. Excellent. So now that we're logged into Docker, now we can Docker push and get that into our Azure Container Registry. Perfect. The next thing we want to do is kubectl apply-fk8s.yaml, and that will run our Kubernetes YAML file into our Kubernetes cluster. Well, in a similar way, we need to log into Kubernetes. So we do have a secret here that is our kube config. That kube config came from inside of the inside my user profile. Inside the .cube folder, there's a config file, and I'm definitely not going to open that one. It has actual secrets in here. But there's that base 64 encoded cert and the base 64 encoded cert and key. And so I just need to pick out those parts of that kube config that represents my production deployment. So I grab that, I set that in the secret, and so now let's go reference that as we log in. So let's come back to the marketplace and we'll search for Kubernetes set context. That one looks great. Let's grab that YAML right there and indent it a little bit differently. There we go. And so what is our method? Well, kube config, we've got that kube config secret there. And because we have the kube config, we can set the secret here to secrets.kubeconfig. And then we can remove all the rest of these. These are parameters for the other methods of authenticating. And now we are authenticated into our Kubernetes cluster. We're able to now run Kubernetes commands on that cluster as part of our build. Now, one of the things that we had done here inside this Kubernetes YAML file is we have these replacement expressions. DB user, we have image label, ACR URL, AKS URL is down here. And we want to be able to leverage these secrets or these configuration values inside of our build. So we could definitely use Helm, and Helm might be a great solution here, but it might be a little bit overkill for this small project. So instead, I'm going to grab this sed expression that will do some of that work for us. Here's that sed expression, and I'm going to wrap so that we can see it. I'm going to sed, without backup, the text ACR URL with the value of that secret, the text AKS URL with the value of that secret, the text image label with the GitHub SHA, and I will do all that inside the Kubernetes YAML file. Cool. So just a quick sed to be able to replace the find and replace inside that text file to be able to get the actual values into place that we need for this Kubernetes YAML file. So here's our build. We'll run on Ubuntu. We'll check out our latest code. We'll log into Docker using all those secrets. We don't have any secrets embedded in our DevOps pipeline. They're all secrets inside of GitHub's secret manager. We'll log into Kubernetes. We're still not putting secrets in our build file. We'll Docker build. That will run all of the steps here in this Docker file. Build, test, and publish. We have those multi-stage builds in place. Then we will push that to our container registry. We will replace those expressions, and we'll finally run that inside of Kubernetes. Now, I chose specifically to put this sed line here, because if I put this sed line here, and if, say, for example, we come back into our Docker ignore, and somebody forgot to put in the k8s.yaml file here in the non-production files, then we might copy those secrets into our container, and now if you were able to pop my production container, you could get my deployment secrets as well. So let's not do that. Let's instead move this sed line down to after we've pushed this to the registry. The secrets don't even exist in that file until after the container is already gone and in our container registry. Perfect. So now let's come here. Let's commit this change. Create DevOps pipeline. And we will commit that change. Now the cool part is that, I called it blank.yaml. That's entertaining. This is just one of the regular files inside of my repository. So I can do a git pull, and then I will see this file appear inside my repository. There's that file, and I can just interact with it as a regular file, along with all the other things that I'm doing. Cool. Now, that means I can continue editing it here, but I can also continue editing it here. I can just pop open this file. I can click Edit. I'm back in that developer experience with the marketplace, and I can start to drag in additional tasks. But because it's in the .github/workflows folder, and because I've enabled it, then we get a build that kicks off, which, by the way, failed. Why did it fail? Because I typoed the csproj file in my Docker file. Let's go fix that typo. Yeah, it's not nested in a folder. Fix typo. Let's commit that and push it. Git push. And we'll kick off another build. Cool. So this build is going to then do each of the steps in our DevOps pipeline. So let's take a look at that. It logs into Docker. It logs into Kubernetes. It's going to run each of the steps of our Docker file. And once it finishes that task, it's going to push that up to Kubernetes. So right now, kubectl get all. I don't have anything in Kubernetes yet, so it will create new resources. That's perfect. Let's see what the build's going to do. The build's going to wait for a runner. Oh, there we go. So we did all of those steps. We pushed that up to our container registry. We started that in Kubernetes. And so if we come back over here, we can see those resources are now in Kubernetes. Cool. Now, Kubernetes and DNS takes a while to propagate. So instead of waiting for this host to show up, I'm just going to jump straight in place. We can take a look at how we might use Kubernetes port forwarding to dig directly into that. Now, we could definitely port forward into a pod. There we go. Port forward into a pod. Or we could port forward into a deployment. It'll pick a random pod. We can port forward into a service. We can't port forward into an ingress, but skipping the ingress because DNS takes a while, let's port forward straight into this service. kubectl port forward service / level up DevOps. We'll go from port 8080 on our local machine to port 8080 inside that service. Now, this isn't going to return right away because it's got that connection live to it. And let's come over here, and we'll go to localhost 8080, and we see our website running in the cloud right now, the one that didn't exist an hour ago. Woohoo! That was awesome! We did a DevOps pipeline from start to finish and got this deployed into a container running in Kubernetes. Now let's take a look at pull requests because we set that one aside for a bit. I want to come back here into my build, and let's copy this build and create a new build. I'm going to create this new build that is dockerpr.yaml. And I could definitely create conditions here. I could say condition, or if the build was on a certain branch, and I could jump around there. But in this case, our build will be substantively different. So we'll do this as a separate build file instead. Build a PR. And so I want to run this on branches that are not main. And I also want to do this on pull request. That I'll do this on any pull request branch. Now, why do we have both? Well, for internal collaborators, people who are part of our project, they're probably going to create a new branch. Maybe it's feature / something, and then they'll want to merge that back in. So this top one will grab that build. For external collaborators, people on the internet who fork the repository and create a pull request back into our repository, they'll come in through this reference. And so they'll create pull requests into our repository, and it'll kick off the build here. So we have one for internal collaborators and one for external collaborators. Excellent. Now, what do we want to do? Well, we probably don't want to run this pull request in Kubernetes because, well, that's our production environment, so let's not do that. Well, if we're not going to run stuff in Kubernetes, we don't need to log into Kubernetes, which probably means we also don't need to set the secrets in our Kubernetes YAML file. Our build is getting simpler. That's cool. Let's also not push this image to our Azure Container Registry. We don't want some random PR image to accidentally get pushed into production someday. We probably want to rebuild it. And so we probably don't even need to log into Docker either. So let's remove that. To that end, I'm not even going to reference this secret right here. I will just say that your container is named levelupdevops-pr. We're not going to push it anywhere. We don't need that registry name. It just eliminates another secret. Cool. So we've got this new build file. And let's also come back into this README. And let's add a tag. So let's go back into that build. And we'll take a look at this build run. And we'll come here and we'll say, I would like to create a status badge. Copy that status badge. And let's set that right there. Cool. So we've got our status badge. We've got our pull request build. And we're going to commit this then to our main branch. So, we've also got that changes. Good thing that somebody remembered to ignore that Kubernetes YAML file so we don't accidentally deploy that. And so we're going to say add PR build and status badge and commit that. Now, last time we pushed from the command line. This time, let's push from VS Code. And so we'll push that into our GitHub repository. And so now there's that new run there. And it's going to kick off a build. Last time we went in this way. This time, let's come in this way. Here's that new build. And so it's going to do each of those steps. It's going to start off logging into Docker, then it will log into Kubernetes, then it will start doing all of those steps in our Docker file, and so it will kick off a Docker build. It's copying the stuff. Is it going to succeed in our build? Yep, our build succeeded. We have no tests, so we have no failing tests, so that succeeded. Let's publish our thing into the other image, and we'll push that image up to our GitHub, our Azure Container Registry. We will now start that image inside of Kubernetes, and now our build succeeded. Great, we've got our new version inside of Kubernetes. Well, how do we know that the new version got deployed? Well, let's take a look at this. kubectl get all. Now, one of the things that we did was we very specifically created this label on our pod that said that image label. And in our DevOps pipeline, we went and found that image label, and we replaced it with the GitHub hash. So let's take a look at that resource. kubectl describe pod / this level up DevOps one, the one that's running. Oh, nope, the one that's pending. Right here. I bet it's running by now, though. And let's take a look at that content. Well, we have a bunch of stuff. It's triggered. It's looking for an available node. It's here's our limits on it. And here's our version, 8F849BE. If we come back into our source code, we can see 8F849BE is the git commit that we just pushed. So now we can really easily get from the running resources to the source code that created it. I would even go a step farther and put it on the web page down in the legal things, that git hash, so that if somebody sends me a screenshot of the website, I can say, oh, I know exactly what git commit I need to check out to be able to replicate your issue. Excellent. So we have that running. And we also have that PR build in place. And this code is now up on GitHub, starting with our empty repo. We did it. Thanks for coming.
Okay. Come on. A lot of people. Looks good. Welcome everyone to this session where I'm going to share a bit on what we have learned moving the Elköp sites to Next.js and hosting them on Vercel the last couple of years, or we did a work the last year. The presentation will have sort of two parts to it. I will first talk a bit on how you can make these kind of changes in a large organization, because it was not obvious that we should do it. So how do you actually get can you sell this kind of project to a large traditional organization? Because I don't think we as developers are as good as we probably should be on doing that. And the second part is, of course, like the technical aspect on what we have learned. And most focus will, of course, be on those things and learnings from how Next.js works, and also some learnings from Vercel. So if any one of you have used any one of our sites in the Nordics the last couple of years, you might have seen something like is it your left or right? I think it's your left, yeah, left side. And it's not me that had like removed the prices from the products. This was actual how the site looked like from time to time. And I think that could maybe be fine if the prices were actually streamed in a reasonable time. But most of the time you should get the prices right away, in my opinion. But this screenshot, the prices were gone as long as I had the time to actually open up the screenshot tool and take the screenshot, which took more than 30 seconds for me. And that's definitely not the experience any customer should have visiting an e-commerce site. Like, you should see the product, and it should be snappy, and it should be fast. And I don't know about you, but my patience is not that long. So if I would experience it myself, I would actually go to another site. Unless there was some super good offers, of course. And we try to have those from time to time, but not all the time. So it's not like great experience. And you can also see there from at least 2 comments, but there are many more on Reddit if you really want to look into it. But one, if you translate the first one, it says something like, a horrible site, I went somewhere else. Basically what I said. And then we have the second one is, I work for Elköp, I'm as frustrated as you, basically. And it sort of hurts as a developer to actually read those comments, especially for your own company. I was not responsible for the site before this, so it was not my fault in a way, but it still hurts. Like, I still take pride of where I work, and I want to my company to do as good as they can. And this is not good enough. That's how easy it is. So this is sort of, I'm going to share a journey of how we went from what you see on your left-hand side to what you have on the right-hand side. Like, you don't see the site there, but this is a score from Vercel, which is based on the core web vitals, which is the thing Google used to as input for the SEO ranking. So having good core web vitals is crucial for an e-commerce site. That doesn't necessarily mean the site is excellent, because there are ways you can actually have good core web vitals but a crappy site. But at least it gives you something to work with. And just to show that this is not the trick data, this was also from the PageSpeed insight that we're actually doing fairly well now on desktop. And before this, on the old site, we were struggling to be sort of average. Now we are pushing good all the time. This was for desktop. Mobile, we are actually not good on IMP yet, due for various reasons. I still think we have some legacy data, because this is a 28 days sliding average, and we haven't been 100% live for 28 days yet, but soon. But we'll see if we're going to make it there. But also remember, like, what we have live now is basically the first version what we have done. There's still like more optimizations we can do. So this is a great starting point for where you want to be as an e-commerce site. You want to have good SEO scores and good user experience. So I think we succeeded on that part at least. So before moving on, a short introduction about me. My name is Thomas Jansson. I work at Elköp Nordic, as I said, as a principal software engineer. I've been there for about 4 years. And one funny thing, like when I joined Elköp, I had a fellow speaker at the conference who asked me, when will you fix the site? and it took about 4 years to get there, and hopefully we can improve it even further. I wasn't hired to actually work with the site, but I ended up there eventually. I do get a bit older, I realize. I've been like programming for food for 20 years now. I started up doing Perl programming in VMware in 2004, so I have a 20 years anniversary today. But I've been also through like ABAP programming, SAP, super exciting stuff. Java, of course, as exciting almost. C#, F#, and all like web things out there. Not all web things because that would drown me, but at least like a lot of different web technologies. I try to focus much possible on delivering value, and I think you can deliver value in many different areas, of course. One is building the applications, but you can also deliver value of enabling teams and helping like with architecture and making things be more effective in all kinds of ways. And I also really a strong believer in like you need to continue to change. If you want to improve, you need to change. Of course, not all change is good, but then you just need to change again. That's how easy it is. And I don't care too much where I work, if I work with infrastructure or front end, back end, or whatever. As long as I feel I can have some significant impact where I'm working, I'm quite happy. And right now, that is rebuilding our site. And that's definitely been the most fun project I've been on in my career, because not every day you get to work on a site with a really small team. We are only 6 developers, I think. But to work on a site that impacts or have the customer base is all on Nordics, basically. So it's quite a large site, I would say. So how do you get to do such a rewrite in the first place? So like, if you didn't notice, but our old site was sort of finished about 1.5 years ago. And then I think it's quite early to start a rewrite already now. So you have to get to that decision, you have to really make a good sort of sales pitch in a way. And that's something we as developers really have to better at. And it's hard for us developers to be heard sometimes in all traditional developments because we doesn't say the right thing, I think. And I also think it's a more problem in traditional organizations because we don't sell software. We don't sell services or software services. We sell consumer goods at the Elkjøp. And a banking sells banking services or something like that. And let's face it, almost all companies we work for are more traditional. Most of us that work for Microsoft or Google, we work for banking, insurance, retailers, etc. So it could be hard sometimes to actually sell in those things. So let's see what you can do to maybe increase your chances of getting heard. At least it worked for me. So hopefully it can maybe work for you as well. First thing is, I think you should start not selling the technology itself. You should focus on the problem, or rather like, what's the thing you want to improve? Because like, technology, I understand why we would actually start talking about technology. That's quite easy for us. We know tech. We are comfortable talking about technology. We are not as good maybe on the business side of things. But we need to understand what the problem we're trying to solve, and that's just, here's another JavaScript framework that's going to solve everything. We need to have some kind of better understanding of what is it we want to solve. And really, like, the management or shareholders, etc., they don't care about technology, like on average. Of course, there may be one that does or something, but they want to have happy customers, more revenue, and lower cost. That's how easy it is. So if you want to get heard by them, you need to sell that to them. You can't sell them a new JavaScript framework. They don't care. As long as it doesn't impact what they are sort of measured on, which is most likely the stock price, they don't care. And now when we know that we should sell the problem, we also need to do the math. Just saying, oh, here was the problem we need to solve. Okay, what's the impact? And I think that's sort of the reason why the business almost as a better or stronger argument when they are presenting their solutions they want to have fixed, because they sit there in the spreadsheet and making sort of estimates on all kind of things. Like if you're doing this thing, we're going to have this much more revenue, or if we do Y, we're going to cut down cost. And for us to be heard, we need to speak the same language. And we can get hold of the same data if we want to. You can get rough estimate. You know how many sort of developers or outsourcing partners you have, or how much time you spend on bug fixing, etc. Try to estimate how much that might cost. And then try to see, okay, how much can you maybe improve that? In this specific scenario, I was mainly actually focusing on cutting down cost for driving our e-commerce site, because that's had almost got out of hand, I would say. And we want to lower cost, but at the same time, I hopefully think that the revenue increase will be even bigger over time. It's sort of, that part is hard for us to measure, because we have sort of the macroeconomic picture to take into consideration, and that impacts sales probably more than if we have a nice looking site. But cost is something that's really tangible for us to look at. So that's what we actually focus on. Like, we're going to try to drive down cost quite a lot. And when you do this, you probably need to do some assumptions as well. That's perfectly fine. The business make assumptions all the time, because you don't know how things are going to pay out in the future. But at least give some reasonable assumption and try at least. And you can be wrong, but that should be fine. Another important thing, I think, is to pair up with someone or a group of people when you do this. Because let's face it, most of us might be the best on the business side of things. I'm definitely not. So it's good to get someone else to sort of validate your thinking and challenge also your thinking. And in my case, I actually paired up with 3 more people, 2 more developers, where we actually could create a really early proof of concept that this can work. And then I have one more, little more business-oriented, so we could get a stronger business case, which really helps, and also validate all the numbers, and he helped gathering the data I was talking about in the previous slide. And just getting there and having these people to work with is just one part of it. But I think the most important part with that is to get your sort of first follower, I would say. Because you don't have anyone that believe in what you're trying to do and what you want to fix. How are you going to convince the management that it will work? So having these first followers is something that's crucial. And it also makes the work hopefully more fun. If at least you pair up with someone you actually like working with, which I did. So we had a good time doing this. So I think that's definitely something that's crucial for anything like this to actually succeed. So now when you have, you need to do the math, you have someone to work with, it's time for you to actually tell the world or the rest of the organization, this is what you do. Maybe not go directly to all organization right at once. And this is also where it's good to have this other person to work with, because your network have already grown quite a lot inside the organization. So now you can find the right people to talk to and create a solid business case to present to them, and try to get the right people in the room. And if you can't get them there, it's going to be tough to actually make big changes, depending on what your organization looks like, of course. But it's important to have this presentation to point to and refer to. And if you actually can, I definitely think that having a rough proof of concept ready already, that makes things even easier for people to make a decision. And we had a rough proof of concept of sort of search and other things done in a couple of days. It doesn't have to take too much time. But yes, that made people more comfortable with all this. And also when you are trying to pitch the thing you are selling, be clear to have a plan. Present the problem in a clear way and how, what a potential outcome, what you want to do. And the only thing we actually sold in this first presentation was, can we just get 2 months that we can focus on this work? It was me and 2 other developers at that time, and see what we can do. And we over-delivered, I would say, in these 2 months. So we created a lot of things, but there were a lot of things remaining. But that gave everyone the extra confidence, and it sort of validated our assumption that we could deliver, and then we could make the final commitment that we are going to go this direction. Because if you're working for a large organization, investing 2 months for 3 people, that's basically nothing for most larger organizations. Especially if we have an older one that's used to running super large project with 50, 60, 70, 100 people for years, then 3 people, 2 months is a rounding error almost. So that could be one way of selling in what we do. Ask for a time-boxed time, and you work with those time-boxed and deliver as much as you can. Some people will come with arguments saying, oh, timing is bad. But that, I think that's sort of one of the worst arguments that there is, I would say. You have to say, why is timing bad? Because, let's face it, timing is always bad. The best thing in our case would probably been not to make the previous decision 2, 3 years ago, or 4 years ago, maybe. But we can't travel back in time. So most likely, the best time of doing this is now. Worst time is probably tomorrow. So, but I agree, timing is bad, but someone just needs to make that decision and live with it. So that's also why it's important to know what you ask for, and that's why we limited it down to ask for only 2 months to begin with. This sort of concludes sort of the part of how you might be able to sell in something like this. Because it was a big change for Elkjøp. We had invested a significant amount of money in the previous site that we've been running for a couple of years, and many more developers than 6. So making this decision almost sounded too good to be true. And it's hard to make those decisions also, even though it sounds too good to be true. But it was true. So why did we choose Next, and why might you consider doing Next? That's something I hope I will cover for the rest of the talk. And to be able to make a good decision, I try to think about, at least when it comes to web development, I can think about the applications on a spectrum of application. On one end, you have sort of fully static applications. And on the other end, you have fully dynamic applications. And with static, I basically mean a blog, or you can basically server-side render everything, make them fully static, serve everything from a CDN. That should be super fast and great experience for users. Dynamic part is like a stock trading application or online game or something like that. Maybe you shouldn't do an online game in web, depending on what you're doing, but that's more to a dynamic side of things. And to choose the right tool, you probably need to know where on this spectrum you are, because different tools have different, is catering for different part of the spectrum. And some can be, of course, over the whole spectrum, but they are probably better in one way or another. Our previous site was actually done using Angular. I'm not going to talk too much about Angular, but my opinion about Angular is that it's definitely targeting more towards the dynamic part of a site, where you have like two-way data binding and things updating here, where you have like reactive extensions and all things happening out of sync and or not happening at all. And that's not ideal for an e-commerce site, in my opinion, because as I said, e-commerce is more like a blog than it is a game. So we would rather have something that can actually create a finished HTML for you and then just give that to the customer, rather than have this sort of dynamic page where things happening without control in a site. And to try to sort of make this or Angular or this so dynamic part work in a static way, you're sort of fighting against the framework, and that's not a place where I never want to be. because then that means you have probably chosen the wrong tool for the job. So that's why I think it's so important to know where you are in the spectrum, so you can choose a tool that might work for you. I think you can make an e-commerce site with Angular. I just think that's going to be much more work than many other solutions. And one other important part here is like you should choose something that you think is fun. So if you don't think Next.js sounds fun or is fun, you should choose something else. But know where you are on the spectrum and don't choose something that doesn't fit for your purpose. And I said we chose then Next.js, which I think is quite broad. It catering, I think, almost the whole spectrum, but definitely more towards like the static part. And you have like server rendering as default now, but it's super easy to opt into client-side interactivity and that. And that will also, like now when Next.js 13, or when Next.js 13 came, now we are on 15 almost, and app router, that was even more pushed towards server-side rendering for Next.js applications, which is good for an e-commerce site, because we want to render the HTML that we can cache and serve in a fast manner to our customers. And one more thing before moving on, like we choose Next.js because it's sort of the boring choice in a way as well, or really safe choice. It would maybe be more exciting to choose like HTMX, Svelte, or some other interesting topic, or programming language, or whatever. But you also need to consider the sort of which pool of developers do you have? Do you have any group of people who wants to work in a different technology? Because like you can't enforce or force a new technology if you don't have the critical mass of developer interesting and wanted to invest in that technology. So that's also why choosing Next was a safe bet for us, because almost all web developers know React by now, and Next.js is just a really opinionated way of writing React applications, both on the client and on the server. So let's talk a bit about what we learned. As I said, Next.js is very opinionated. So if you don't like the opinions of Next.js, go and pick something else. Like life is too short to work with something you don't like. I don't agree with everything in Next.js, but at least this gives me enough, or they thought about more things than I have thought about when it comes to web development, and I can definitely live with the things I don't agree with, because I understand them and can definitely appreciate the other things much more. And I haven't had any sort of things that prevented me of doing things, so I definitely think Next.js is a solid piece of technology to choose. And I don't like sort of reinventing things. I like to focus on what I think I should be solving now. And when I'm doing the e-commerce site, the focus should be on writing the e-commerce site. I don't want to focus on writing a build pipeline, or I don't want to focus on doing the infrastructure part. That should be solved for me. And that's sort of what I got for free when I'm using Next.js, and especially together with Vercel. And that makes me able to deliver value much faster. So let's talk a bit more about Edge runtime. Edge is sort of ambiguous, I think. It means a lot of things for many people. In the context of Vercel and X, it basically means having code run on sort of edge nodes close to your users. And that sounds really good, because the distance is smaller, so the communication should be fast, right? And that's what we thought. And Vercel actually pushed this quite a lot when we started developing our site. So we went with it and went 100% on Edge for everything, which was not a great choice, to be honest. That's why we went to the Edge and back. And we started seeing, like, it worked fine when we were like 1 or 2 users browsing the site. All the metrics looks good. But soon we had more people consuming the site. We started seeing some latencies, and the metrics on the speed inside wasn't as good as we thought they would be. So that got us sort of thinking about, is Edge really the thing we should do? And I think it isn't. Because most of the time when you have this Edge, you have sort of the application running on Edge close to the client, which looks good in a way. But at the same time, you will have a much longer distance from that application to all the APIs or the database if you have that. And in our scenario, we have quite a lot of APIs to just render any page, basically. So that we get a really large penalty for running on the edge. So what we did was actually moving back to sort of serverless, which you can switch in Vercel. They have both edge and you can have serverless, which is basically wrapping around AWS Lambda, I think. And so we made the move back to serverless, and that comes also with another advantage, because if you're on edge, you can't have static pages that you can cache. So every page visit on edge is a full render of the application, which is good in one way, because you can do some amazing things around personalization if you render every single request. And it doesn't cost you too much, and it is quite fast if you have the data close to the edge node. But we didn't have that, so that's sort of why it failed. But instead, we now are on serverless. We can start generating pages that we can cache, and cache pages is something you can serve on CDN really fast. So that's sort of what gave us the performance. And we decided to move from edge to serverless like 1 or 2 days before we went from sort of 10% of traffic to 100%. And we managed to make the final switch like 1 or 2 hours before you turn the switch on to 100%. And we had a fixed time for that day because we were also starting a campaign on the same time. So it was interesting to see, like, could we handle the extra traffic that came that day? And we did. And performance has been sort of in the roof since day one with that move. So that's a great choice. Let's talk about routing in Next.js. That's one of the things that some doesn't like. I did not like routing in Next.js when I started doing it. I accepted it, but I came to like it more and more as time goes. Ideally, like when I started using Next.js, I was more used to defining routes in one file, for example, mainly for more like backend development, creating APIs. So that made more sense to me. But now they have a file-based thing, and some might comment, oh, how do I find the actual page for the specific route, etc., when all the files are named the same, which they are. You have like, only in this screen here, we have 5, 6, 7 page files. But in most IDEs, you can search for the file by entering the folder name instead of the page name. So it's quite easy to navigate the files when you get used to it. I haven't had any problems when after like a couple of minutes. The first couple of minutes were tough, but I got over it. And we have some different elements here. We have the folders defining the route or different route segments. We have a layout file which defines how things should look and feel, etc., on a high level. We'll come back to that. Then pages file are defining so the actual content on each page on that route. You have dynamic route, meaning if like order /ID, for example, you do that with a square brackets. Then you can put in either like one name of a parameter, and then that will be available to you in the page, or you can have like a ... beforehand to make sort of a catch-all route, which is also useful if you have try to have some SEO-friendly name of routes. You might need to have these catch-all things. We also have these route groups. You see it in the example here in the top where the parenthesis account. That's a way of grouping sort of similar routes together, and that account part will not be part of the URL. It's just one way for you to group things that belong together. And then you can either sort of apply a common layout to those pages, or you can just use it for grouping purposes if you want to. If you have an underscore folder name, that will also not be part of the route. And that can also be good for then gather things like components and keep them close for your page if you want that. We are sort of mixing both, having sort of local components close to a page that are only used on a page, and then we have like a components folder in the root that are more common for all the pages. So I said a little bit about pages and layouts. My opinion, I think they have solved pages pretty well in Next. Make it super easy to create sort of sophisticated layouts. And they also have a concept called parallel routes that I won't be covering today. If you want to know more about it, you can catch me on the floor afterwards, and I can explain that as well. But layouts is where you define sort of how a group of pages should look like. So everything sort of below that layout in the folder structure will inherit that layout page. And you can also have sort of nested layouts, as you see here. Like you have the top page there, which have the gray box with an arrow, and that the other layout here will then actually put this context inside this larger box. And every page will then fill this space underneath this layout. And that can go on and on in the folder structure. So I have a super simple demo for it. So when I refresh the page here, you actually see it's flashing can you see the green flash on the screen? I hope it's good enough contrast of what's loaded. And you have both Next is both SPA and an MPA, I would say. So both like a single page application and multi-page application at once. When I do a full refresh of the page, I get the whole HTML for the whole page. But I also get client-side navigation out of the box with Vercel. So when I click the links here, I will only replace the part in the layout. So it has this whole shell quite stable all the time. So if I drill down to the other page, we'll actually see that only the inner layout is now replaced. And that makes a pretty good experience, in my opinion. We don't leverage this all the time on the Elkjøp site at the moment. We have more serving 100% static pages almost all the time. And that is also super fast in our case, because we don't have too much interactivity in that way. But if you're building sort of a back office application or anything like that, I think this should be super helpful. And we will probably explore this area even more for our e-commerce site as well. The page and layout. React Server Components. I think there's actually a talk about React Server Components only, so there's definitely going to be more to say and talk about the React Server Components than I would be covering here. That was one of the probably newer things in the React ecosystem the last couple of years. And it's not like a next thing. They have one implementation. I think there will be sort of more implementation under the hood for how React Server Components work, but Next.js has its implementation. And it's sort of quite a simple concept that I think we have forgot about in a way when we're doing SPAs for 10 years, where everything is sort of rendered on the server, or on the client instead of on the server. React Server Components basically mean render the thing on the server and deliver the HTML, more like how the web was intended to be used from the beginning. And that will also give a better, most of the time it will be better performance for you because you're going to ship much less JavaScript. When you're using Next.js with App Router or the new App Router, which is not that new any longer, everything is a server component by default. And what that means is basically everything is going to be server rendered as default, and then you're going to ship HTML if you don't do anything else. There will, of course, be a slight overhead with JavaScript for the Next.js sort of framework, but except from that, everything else will be pure HTML if you don't do anything. So if you don't have any interactivity or anything on your page, everything here, as you see in the component tree I drew to the right, everything is considered to be a server component. And the way you are actually creating a client component is you are using sort of a directive in the top of a file saying use client. And that basically just means, or sort of marking a border saying, okay, in this file and onward, I'm going to have some interactivity. So I need to run on the server, client as well. But that does not mean you're not running on the server. You will first have the initial render on the server and then hydrate on the client, as it's always been with React, I think, in doing things. So if we mark one thing as a client, then you would have like one client component, the green box here. And if that client component is using or instantiating other client components, they will also be made client components. So now I've marked two other boxes blue because they sort of inherited the state from the component above. And the blue components, they doesn't have to have sort of use client at top, as long as the one above has it. Because they will know, or the runtime will know, okay, this is sort of a runtime context now. But this is not always what you want to achieve, to be honest, because this will maybe make you deliver more JavaScript to the client than you actually need to. So there are ways to actually achieving this in the tree, sort of. I don't know how to draw the arrows in a better way, but you can actually get a client component in the middle of the tree and then get the child to almost be server component again. And the way to do that is, instead of having the client component instantiating the component or the child components, you are passing them in from the server context. Then they will be already server-side rendered and not you don't need to ship the extra JavaScript. A simple demo of how that can look. So here I have taken out like the most important part of it. I have this really weird component called server client, which I can quickly show it. It's here. So it will actually, if I can run use effect, then that means I am on the client. And if I can't, I'm on the server. So it will actually turn green when it is on the client, and red when it is green when it's on server, and red when it's on the client. So I have my page here in the code, and it has the server client. It's still green, meaning it still runs on the server. Then I have my client component, with also instantiating a server client, as I call it here, and that's what you see here. That turned red in this scenario because it was instantiated from a client component, so it sort of inherited that it is in a client. But I'm also passing in like a server client, which also have a server client in it, and those are still green because they are still running on the server. And this is what you most of the time want to do when you're working with React server components in Next.js. Because you want to, if it can run on the server, it is definitely beneficial for you to run on the server. You don't need to ship as much JavaScript, and it will be faster, it will render faster, and everything will be just nice and looking good. That was that. So internationalization, that's a super interesting topic, I think. And this is more about middleware, but we use middleware to solve internationalization. The problem was internationalization, the solution in our case was using Next.js middleware. And when we started using App Router, there was no solution for this in the Next.js space, because App Router was quite new. I don't even think there is a good solution for it now either. I haven't looked because we haven't had a need to. Because there was a solution, but they were targeting so the Pages router, which was the router that was before the App Router in Next.js. And the way we went about this is, okay, we have this concept called middleware in Next.js. It runs before your application. And in the middleware, you can basically do anything you want with a request or the response. And it has the benefit that you can actually read cookies, headers, request parameters, etc., without impacting the application. If you do those things in an application, you would actually start turning the application dynamic. And that's something you want to avoid in a lot of scenarios, because if you turn the application dynamic, you won't be able to cache it in a CDN. So you want to keep the application as static as possible for as long as possible. But in the middleware, you can do it. So what we were doing, we want to solve like two things. I said we have sites in 4 countries, so we need to be able to decide language based on which market we are in Sweden, Finland, Denmark, or Norway. That's one side of it. Another part is when we are using Vercel, you get these nice preview deployments, but they are all sharing host names. But we wanted them to actually not have this like /no, /sc, etc. We wanted to look more like in production when we only have / and the path name. So we wanted to be able to both serve language based on a cookie or the host name. So what we are doing is actually in the middleware, we're checking which host name you're on, and then we are rewriting the actual URL for the application underneath. Might sound like magic, but it's quite easy. We can see in the demo pretty soon. So in the first version when we did this, we only had sort of the market, because we also have like the markets like Norway, Sweden, Denmark. We also have if for B2B or B2C as well. And then that part actually grow. So we'll come back on the next slide as well. So if we're looking at this small demo I created here that show off how middleware works, I will show the URL because that makes sense here. Here you see my nice looking German site at the moment. But what's interesting here is if you look at the URL, I'm not sure if you can see that, it might be too small. It doesn't change no matter what I click here. So if I switch to Italy, it says ciao, I can refresh, it's still Italian, and that's going to be served statically. And what I'm doing here is basically first coming here and checking if I have sort of a language part to the URL, meaning like /no/sc or whatever. Then I'm going to set a cookie telling which language are you actually looking for. And then I'm redirecting to the path without the language part. And then I will, the next time I go here, I will get to this state and say that, okay, I have this language cookie. Then I can serve the site by rewriting the URL and inserting the language part back again. This way I can actually serve sort of static content without any big problems, to be honest. And it's going to be more interesting. I'm not going to show the code for the next part, but I can explain the part for the next feature I'm going to show. And then the part below here is actually just how you say when the middleware should run. Since I have many demos, I'm limiting this to only this path. And middleware is like one of the areas I think there are definitely room for improvements in Next.js. I would love to see them be more composable than they are today. It's quite a mess when you have many middlewares. They are better in many other frameworks, in my opinion. But yeah, you can solve it, and it's one thing you should try to master if you're doing it. And middleware is one of those things that actually always run on the edge if you are using Vercel, which is a good thing. So edge runtime is not only bad; it is a lot of good thing. For middleware, it's really good. And the next part, feature toggling, that still goes on the middleware to some degree. At the shop, we are using Launch directly for feature toggling. You can actually go and talk to them down at the floor here. But I'm not going to show Launch directly. I will show how it sort of interact with Vercel and in a simpler way. And feature toggling is something I think everyone knows what feature toggling are, of course. But I really like how they have managed to embed feature toggling and testing in production in Vercel. So what I can do is actually, since I have this, if you haven't realized that now, the slide presentations is also a Next.js application. So I can turn on sort of the Vercel toolbar here, and here I get small feature flags. So I can start checking things from my own session here. So let's say I want to present in light mode. I don't think everything worked with that, but let's see. I can start testing features now directly sort of in production. So this is a way for us to actually ship things to production behind a feature flag, have our internal trial features out in a super nice way without impacting our customers. And that will definitely increase your flow of development because you don't have to wait for, oh, can we deploy this or not? Just put it behind a feature flag and get it out. Much safer. I don't think all the images work with black, so I will actually clear this, and I can turn on other things. And the way it actually works is on Vercel. I have this thing called edge config. Can maybe zoom in. Yeah, a bit. Edge config is, as the name implies, it's a config store running on edge, so it's super fast. I think it's a single-digit latency when you request data from it, especially on Vercel. And when you have Launch directly, of course, you get much more data in edge config. But for a simple thing, you can start doing this yourself. That's quite easy. And then you only need to implement a small route that exposes your different flags. That's all the code I had to get this toolbar working. I don't go need this in detail because you get the sort of helpers from Vercel, both like the verify access and how the API data, etc. works. And this is something you can basically copy from the documentation, and it just works. The feature toggling, server actions, a lot of drama when that was released. I really don't understand all the drama. When they announce server actions, which is basically a way for you to talk to the server from the client in an easy way. And during the announcement, they did that by you sort of inlining the code for the server. And I think actually that was a stupid way of doing it because it looked weird. But that doesn't make it not useful. It's very useful. You don't have to write all the APIs or the backend for front end, etc. if you do it. Instead, you can just use the functions you define on the server almost directly on the client in a type-safe way, if you're using TypeScript and not JavaScript. And that's definitely a really good way and convenient way of doing this. And you can do it both for like form submissions, but also you can hook it up to client-side events. And I can show a quick demo here. So I have this simple form here where I can post something. It will take 3 seconds because it goes down to the server, and then I get a notification, hello NDC. And this is only basic client-side, button clicked, and all this is actually going back to the server, responding back. So none of this sort of logic to doing that is on the client. And it's also quite easy to do. For the form demo, I have this handle submit function which call my action, and my action have this use server directive at top. And that sort of marked the border for like when you're compiling, like this thing is actually going to create sort of the connection from the server to the client for you. Then you don't need to create the APIs and anything. One thing that's important to know about if you do this is you still need to validate the data that comes to the server because it will be an endpoint to some degree under the hood. So you need to do validation, of course. You don't get rid of that magically, but you don't have to write a lot of plumbing. So let's go back to, for the form demo, we also have the client demo, which is as simple. I have this handle click, which calls the button click action from my client component, and that's how easy it is to actually getting the client and server to work together using server actions. And that's, I think, our preferred way when we are doing interaction, when we're implementing now. Back to the slides. Caching, another very interesting topic, I think. Caching comes in 2 flavors in Next.js. You have the page cache. I've mentioned it multiple times before. Whenever you're generating a page that will be HTML, you can be able to serve that from a CDN in a cached way, which will be super fast and a really good experience in most scenarios. But they also come with a data cache that you can use. And for Vercel, that's sort of baked in, but you can create your own caching providers if you want to. And there, when they come with Next.js 13, they had the default behavior where they're caching all the fetch requests you're making, which is not made ideal because you're sort of changing the behavior of fetch in Node. And they have sort of reverted back to that on Next.js 15. So if you are doing Next.js, could be good to know about. I think I like that they're going back because that we need to be more explicit on what we're going to cache. And when you have like the data cache and the server cache, it's sort of connected together. So if you have something like the page cache with like 1 hour revalidation time, meaning that's how long you want to cache it for, if that uses data that's only going to be cached for 1 minute, the revalidation time for the page will be 1 minute, because it doesn't make sense to store something 1 hour if the data is just going to be old after 1 minute. And also, if you sort of revalidate the page cache or data cache, that will also trigger a revalidating of the pages. So I think the caching part is something I like quite a lot. And I think they have done a great work when it comes to caching. And also have like a small demo of how that can work, because you can be sort of selective. I don't know exactly. I know it's going to be cat, so it should be safe. And I can revalidate this picture only. So now that's going to go, okay, let's put it twice. Yeah, so now I only revalidating that image. And the other sort of data cache with this picture is from other request, will not be affected when revalidating that. And I have like a 10-second revalidation time on this one, so I should probably get another one if I, yeah, so now I got another one after 10 seconds. And I can revalidate them both at the same time, and now I got 2 new cats in space. Yeah. Partial pre-rendering and streaming. I think this is one of the features not ready yet. They have a release candidate for Next.js 15, and partial pre-rendering is still in beta there. That's one of the things I actually thought was part of App Router when it was first announced, so I didn't understand that, and that's on me. But this is where we definitely want to go when we talk about the e-commerce site. Because when we have the part pre-rendering, you can then serve a sort of a static shell of anything and then stream in dynamic content without making extra network requests. It will be the same request you're doing, so you're only doing one request, you're getting all the HTML, but it will be come at a later point. And that will also work without JavaScript or anything. To achieve the same thing without the streaming part, you would actually need to have JavaScript. And it's sort of like not 100% true. You need to have JavaScript to make the stream content visible. But if you're thinking from a crawler perspective, then you just want to have the content visible for the crawler, and that's perfectly fine to just stream it in and not visible for the eye. And so here you can have, like in this small picture, you can have like this black shell, and then you can like account button or whatever, and on pricing and maybe something else here, or if you like the image or whatnot, that can be streamed in later. And then you are much more free to sort of mix and match static and dynamic content in a much safer way. And I can give you, take listing pages, for example, on a product listing page on an e-commerce site. We can have this static shell for everything around search, and then we can stream in every single filtered page we have. And that's something we can then create a much better user experience with. I have a really short demo here as well. So here you see something there saying, this is sort of static. It actually has like 2-second delay to do this thing here as well, but you don't see it because that's part of the static content. This part here is actually dynamic, so here you actually see it take 2 seconds for it, and then it streams in. And you can do this with JavaScript today as well, with like using SVR or whatever. But the important part is still, this is the same request. I don't do one more request to get this sort of updated content. But there's some JavaScript to make it flash, etc., but it's still the same request. So let's talk about some Vercel features that I think is very... Vercel has definitely been one of the, if not the best sort of developer experience I have experienced when working with sort of cloud platforms. It's never been an easy tool to just write code and then hook up the Vercel to your Git repository, and you have like a deployment pipeline and preview builds, etc. So the development experience is definitely top grade when it comes to Vercel. So one of the main features that we have been using is the deployment features. Every single thing you're pushing to GitHub, we get its own deployment. It's not like you can see it was deployed and you build. You can actually go back in time and click any of these deployments and look at what did the page look like at that point in time. And that's very useful if you have some weird issue in production, and you can go back like 2 or 3 deployments and say, okay, do I have the same issue in this deployment? And it's super easy to like, you get this out of the box. And doing that yourself, that's something I actually did before we started rewriting the page. We did that for our internal site, or for the site on the old platform. But it takes quite a lot of time to get to this level of sophistication, I think. And in fact, for everything of these deployments, it has its own sort of caching space. You have the toolbar connected to that specific commit, which you can make comments on, etc. Next part is, of course, speed insight. Being an e-commerce site, this is actually very important for us. Having good SEO score is crucial, and one of the things we promised to deliver on, and I think we did. And one thing that could be hard to see in this picture here is like there are small annotations in this graph, light gray, and that indicates when you're done sort of production deployment. So if you see that your sort of scores start to go down, you can actually go in and see, okay, at which deployment did this start to happen? We haven't experienced that yet, but we know we can do it if that happens, which I think is very good. And you can also narrow down on things. If you see a specific route that is problematic, you can start filtering that, or a specific page or whatever, so to find where you might have problem. So trying to summarize, doing change in large organization, that's definitely hard. but it's doable. We just need to maybe change the way we communicate with the business and actually present the problem and try to speak the same language. And also like to make this happen and also create a performance application, both the tech and the people you have on is very important. You also need to know the characteristics of the application you're building. Like, is it a static page or is it dynamic? Like, having a good answer to that will help you solve a lot of problems. And from my experience, Next.js helps me focusing on building the application. I don't need to focus on building build pipelines, Webpack, Vite, or whatever. I just mainly write the code and then print, commit, and push, and it's deployed. And that's how easy it should be. I'd really like to do all the other things as well, but it depends on the context. And the same goes for Vercel. It minimizes the work I need to do when it comes to infrastructure part. I get like automatic scaling out of the box. We haven't turn or change anything about the configuration in Vercel, but it still scales out of the box because it's run on a serverless infrastructure. So Vercel is definitely something I recommend. And with that, I would like to thank you all. And while you're thinking which color you should pick on the way out, it could be time for a question or two. Any questions? One up there. Okay. Yeah, so the question was how I feel about the pricing. Good question. It's definitely a premium product for sure. I think the most people that complains about this has probably been startup who has sort of made it, and all of a sudden they see a lot of traffic, will start cost a lot of money. And being a startup, that's sort of unfortunate to some degree, but they maybe should also revisit their pricing model or their value prop if they can't afford the extra customers. But there are definitely I think Vercel is also trying to make it easier to make things cheaper. You should do the right thing. Like if you can serve more static content, then it will be cheaper, etc. But it is definitely a premium product. So you have to consider it like what do you get for it. And in our case, I think the upside is bigger than the cost for it. But it's good to pay. But it's free to get started, and you can get a feeling for how it works. But for all the small companies, I think the pricing per user is sort of quite annoying, I think. But for like getting started, it's easy. But yeah. Another question? Yeah. Yeah. Yeah, the question is like some e-commerce sites are using micro frontends, right? And if we are consider that, we are also using micro frontends in part of application, but that's mainly around my page area where we have some components that we are also using in our in-store solution. So we're leveraging micro frontends in some sense as well. But I actually try to push for taking more and more into the same project just to simplify the overall infrastructure. But we probably have 1 or 2 or 3 micro frontends as well. But I don't believe in the whole thing. That split the application in 1,000 pieces and then try to assemble it. I think it's better to try to gather it together. Any other questions? What did you do? Search. We are as of now we're using FactFinder, which is basically a search engine specializing on e-commerce, because we don't have to do more than just searching. We need to do something called merchandising, where we're actually ranking products and saying products we have campaigns on, etc. So just using something like Elasticsearch would be too simple. Another question? 30 seconds left.
What other frameworks did you consider before choosing?
Not that many, to be honest. And the reason was, as I said before, to drive some big change, you need to have some kind of critical mass of developers who want to work with something else. Otherwise, you will just work with almost against the developers as well. And in that sense, I think React and Next.js was quite a safe choice. I think that's all I had time for. So thank you.
Have we started? All right. Thank you for coming, everyone, to this talk about shipping software. My name is Christian Jansen, and I'm a software developer at the Norwegian Food Safety Authority. And for about the past 10 or 15 years, I've been practicing continuous delivery, which happens to be the topic of this talk. So the goal of this talk is to show you some techniques you can use in your work as software developers to help you achieve continuous delivery. So I want to focus on like the nitty-gritty details of our everyday work. How can you achieve this process? Very basically, I'm going to make you watch me work for a while, and hopefully you'll learn something from it. But before we get to the practicalities, we have to agree on some definitions, because these terms are thrown around a lot and mean a lot of different things to different people. And if you add the abbreviations as well, it gets even more confusing. Some of these abbreviations even mean different things. So CD, does that mean continuous delivery or continuous deployment? Are those different? Who knows? Depends on who you're talking to. So I'll just define these terms for the purpose of this talk, and then we can argue about the meanings later. So we'll start with continuous delivery. It's just 2 words, and the delivery part is about software delivery, putting working software into our users' hands, shipping to production, really. And when does this happen? It happens continuously. How often is that? It's all the time. According to the dictionary, it's uninterrupted in time. So very basically, the goal of this process is that for every change we make to the software, it gets continuously and immediately delivered. That's the whole point. So if you're going to be doing this, you're going to want to have a few systems in place. So if deployment is going to happen, or sorry, delivery is going to happen continuously, you probably do not want to manually construct the production artifact. So you're going to want an automated build process of some sort. And if you have an automated build, you don't want to involve humans in testing your software. So you need some automated tests, and you need enough of them so that you can trust your system to be delivered when they pass, very basically. And then finally, if you automatically update your production environment, you need observability. You need to know what's going on in production. So all of these things are required to participate in continuous delivery, but doing them does not give you continuous delivery in itself. Because the final part is that you have to adapt the way you work with software. And that's really what the point of this talk is. So that moves us on to continuous integration, this other term. Now, this word has a lot of meanings in our industry. But in this context, it means a very specific thing. So imagine that your team is the perfect size, 3 developers. And each of those developers have a local copy of the code on their machine. The integration we're talking about here is simply combining those changes in the upstream Git repo. That's all there is to it. So people tell you that they can sell you continuous integration. They can't sell you this. This is a work process, not a product you can buy. So again, this is supposed to happen continuously. So ideally, everyone's commits would be continuously merged with the other developers' commits. And this is the process part of continuous delivery. And this is what we're going to be looking at. How can we write code that makes this possible? So we have this ideal model of software development. Sorry, I should mention this. Another term for this process is trunk-based development. So trunk is a really outdated term. It really means main-based development, meaning that all the development happens on the main branch. So trunk is what we used to call the main branch in the old days. Right. So here's the ideal process from start to finish. You have some developers, and everyone is working on the main branch on their local computer, and then they push to the main branch on the central Git repository. And in order to do that, they're going to have to pull down the changes from their teammates. And then this happens continuously, frequently, many times throughout the day. And then whenever someone pushes to main, it triggers some automated process that delivers the software. Now, in most cases, deliver the software means update the production environment. But that's not really a requirement. It could be that you have business reasons for not shipping every change all the time. But at the very least, the goal of this process is to not make it a technical limitation. So you should work as if every commit went to production. And then in most cases, you probably also want to do that. So you might ask, why would I want to work in this way? Well, first of all, I'd say that the goal for us as software developers isn't really to write code, but it's to ship software somehow, or solve problems, or whatever you want to call it, but ship software, right? And this process promises to do that with the least amount of ceremony and the fewest amount of hurdles possible. So that, to me as a developer, is intrinsically motivating. But you don't have to be motivated by that, because this is unique in our industry in that it's actually backed by research. There's lots of good research into this process that says that teams that work in this way have better software delivery performance. They create higher quality software, make fewer mistakes, and even have happier developers. Measured how, you may ask? Well, they don't burn out as often, and they are more happy with their jobs, so they don't quit as often. That's probably a good thing. And it's even shown that in organizations that have IT teams working in this way, the entire culture of their organization is improved. So I'm not going to spend any more time convincing you that this is a good idea, but you can go to this website to read about the research. It's pretty substantial. And then we're going to focus on how to do this from now. Let me ask you a question. How many people in this room work like this right now? That's, yeah, pretty good. Some hands. So there's a common deviation from this process that I will now try to describe, which looks like this. You have your developers again. Now they're working on feature branches on their local machines, each working on their feature. Then they push these to the upstream Git repository in separate branches, so the changes are not continually integrated. And then at the end of some piece of work, the developer will create a pull request and invite their teammates to review that code. And eventually, those changes will be merged into the main branch and are now available for the other developers to pull down. And then maybe you have an automated testing and build pipeline after the fact. But like I said, the existence of this pipeline does not make this into continuous delivery. This is more of a batched delivery model. So how many people work in this way today? That's quite a few more hands, which is expected, because this has become essentially the industry norm, even though research says that this is the best way to work. Now, if you're working in this way today, you probably don't think that this looks like a good idea. And there's an understandable reason for that, because when you're in this kind of setup, the kinds of commit you make and the way you approach problem solving is different from how you work in this way. So they're both using Git and they're both making commits, but they are working in a very different way. So you have to change your mindset in order to achieve this and to reap the benefits that the research tells us that we should be able to get. So how do we do this? So I'm going to do some work on stage and show you how I do it to make it possible. And the work I'll be doing will be on a simple project so as not to have to establish too much context. So what you see on screen now is my team's blog. It's not a very exciting application, but it has a list of articles, and you can click and read them. And now our product owner has ordered a new feature. So instead of this boring list of articles, they now want exciting list of articles with pictures and with tags. So this is a whole new feature, and it requires new data, new UI elements, new logic, lots of things. I probably will not be able to finish it in one go. So can I do this on the main branch? Well, let's try. So in order to do this on the main branch, I'm going to have to try to identify some ways of solving this problem that don't break production. For instance, if I just drop in this UI component with the links before I make the tag page, which looks like this, by the way, then my users will get a broken site where some of the links just don't do anything. That doesn't sound good, so I don't want that to happen. So we have to scope it down a little bit. But what I do notice is that this new design has a new design element in many places, and I can start by just creating the design element. That's not going to do any harm, and that can go on the main branch. So I'm going to jump into code now, and fair warning, maybe not all of you use the same programming languages as I do, but that shouldn't be a big problem because the focus now is not on the syntax or the specifics of the code. It's on how we approach the problems and the granularity that we're solving these problems. So I want to create this UI component. Now, luckily, I have a setup that looks like this, where I can preview all the UI components that my site is made up of. So if any of you use Storybook, you know what this is. It's basically the same thing. Now, obviously, this is very simple because it's a very simple site. It doesn't have that interesting of an UI. But I have somewhere where I can work with UI components in isolation. So let's create a new one that's going to look like the thing I ringed out here. And for those of you who worked with HTML in the old days, I'm going to call this the vCard component. Right, so let's put this to the side and then move into some code. So, all right, I can see it. Def scene, that's how I define an example. And then we're going to do the vCard component. This function doesn't exist yet. I'm going to create it soon. And it's going to take some text of some sort. So I'll just say title, Homer J. Simpson. And then I'm going to go create this function. We'll create it here. vCard, and it takes title, and then it just puts the title in an H1. Right. So now, if I do everything correct, it should pop up on the side here. Here are my vCard scenes. So here's the default. OK. So on the right side now, I have a live preview of whatever I'm doing. So I can keep developing this. I want some more data. So remember, we want the image and a name and some text. Now, this UI component, I would like to be able to use for anything that has a round image and some text. So I don't want to name these things exactly as what they're used as here. So we're not going to call it author. We'll just call it title. And similarly, we'll just call it image, which could be this image like of Homer. And then we'll have a body at the bottom that says disgruntled worker, just as an example. Now, nothing happens because my function doesn't render these things. So we'll do image, body, div, vCard, image, and then source, image, and another div. Got to have those divs, man. And then, yeah, something like this. So if we do like this. OK, so that image is probably a little bit too big. So let's go ahead and set a size for it. Width 92, I think, is fine. There we go. So it's starting to look like something. Actually, I have a class I can put on this one, h5. And now I can go ahead and find my CSS file. And I'll say that the vCard should have a display flex. That should put it, yes, perfect. And a round image, please. Border radius 50%. And nothing is happening. OK, round image, fine. OK, and then finally some spacing, right. OK, like I said, specifics is not that important, but now I have something that is looking like the UI element I wanted. So let me create another example. So we'll say vcard no body. If there's no body, and we'll do another character here. Krusty, here we go. So, okay, now I have 2 examples. So I'm not too happy with this alignment here. So actually, let's go into the CSS and do align items center. Come on. Yes, okay. Pretty good. One more example before we quit this. I want to have something that looks like the thing we're going to use eventually. And that is to have a body with links. So instead of this, we'll just do a span, and this says about, and then some link. Don't care where it points, and it says clowns and TV. Okay, cool. This is exactly what I need for later. So what I did now is just to create a new standalone UI component. It's not used by my code in any way, so I can safely now commit this on main and push it to the other developers on my team. That's not going to make any change for the production code, but it is going to allow my teammates to get access to this code. Maybe they can use it, or at least they can merge it with their code to avoid any potential merge conflicts. So this is great. Add new UI component for vcard. Terrible. Okay, cool. That was one commit. What's the next thing I can do? Well, I'm actually not noticing that I don't have the tags yet, so getting this put on the page is a bit far cry from where I'm now. But if you take a look at what the blog looks like currently, if we go here, it looks kind of drab. So I'm guessing that just plopping that element with the picture of the author would be a good improvement, even if it's not the exact design we want to end up with. So what I can do is to scope that feature down and solve that and put that in production. That will give me some of the value of the new feature before it's all done. So in order to do that, we're going to change one more UI element. So we have the teasers. They look like this. So now I'm going to say that the teaser can have a vcard aside, or whatever you want to call it. So we'll go in here, create a new example. Let's say with aside. Remove that one, and then we do aside, and here's the data. And then it should render on the side here. Here we go. But it's not rendering the thing yet because I haven't rendered it, obviously. So I'll go into this function. There we go, aside, and then we'll go all the way down here. When I get an aside, I will add an aside, teaser, aside, and then we'll call the vcard function with the data that was passed in. Writing and talking, it's difficult. Okay, so this is essentially the look that I'm going for. But now, this is a complete work in itself, right? So let me just commit that. So it's not a lot of code, but it is a commit. So making these tiny commits makes the commit history very pleasant to read and easier for my colleagues to review and check out. So add support for vcards on teasers. That's something. I can push this on main as well. Next up, I'm going to go into where my blog page is being made now and make sure we actually use this new component. So if we go here, let's see where my teasers are. Here's my teaser. So all I have to do now is to add aside and then say title, which should be the name of the author, which is here, and an image, which should be the author photo, and boom. Yeah, I have authors. This is not the entire feature that was specified, but it's some of it, and it's has some value. But now my name is over here, so let's get rid of that. Have to go into my dictionary. Like I said, the specifics of the syntax, not all that important. That's why I'm doing this quickly. But hopefully you can tell that I'm working in really small increments all the time. And that's not just because this is such a trivial site. You can always work in this way, no matter how complex the application itself is. So this is great. Another commit. Onwards to tags. So display author in vcard on teasers. OK. To get any further with this feature, I'm going to need to have some tags on these posts. And let's find a post. This is, OK, so it says queues in practice, locale. There are no tags here. Actually, there's no way to add tags here because the data model doesn't support it yet. So I'm going to have to do that. But that seems like an important design decision, how we do that. So probably I should create a branch, make a suggestion, create a pull request, and have a teammate review it, right? But then I'd have to make the entire thing first and then ask if it's a good idea. My colleague's probably not going to tell me the truth. So if only I could discuss this with someone up front. If like I had a teammate, oh, there's one right there. Would you like to join me, sir? So it turns out that the guy is pictured here was sitting right there. It's pretty lucky for me. So let's do some pair programming to get some tags on here. Okay. So what do you think? How do we store tags on these posts?
You're putting me on the spot right now. Well, we do like a keyword.
Yeah.
So blog post tags, I guess.
OK. And then what goes in there? Like the tag name? Then I'd have to type it the right way every time. So use a keyword, right?
Yeah.
Like this?
I agree. We can use keywords.
Yeah.
The thing that I wonder about is, can you use any keyword?
I don't know. Maybe we need to define the tags some central place first? That will be very cumbersome to use.
It will be cumbersome, but we get a few advantages because we can validate that you have used tags that are known to exist, and well, maybe it's not worth it.
Probably not worth it for a blog, right? But if we only allow them inline like this, then we would need some way to turn them into a nice name, because as you can see in the design sketch, it says closure with a big C and nats with all capital letters.
That's a very clever example. Yes. But how do we then, we could type out the keywords just like that.
Just like that, yeah? But then
it's allowed. It's not.
What happens if I do this? Is that OK?
That's a problem. Those are different, right?
Yeah, those are different. Yeah.
So but we could sort of just create a lookup for the weirdly spelled ones.
Yeah, just treat the special ones.
Yeah.
Yeah, that sounds like it. So we'll store it like this. So let me just open the. Here's my schema, right?
Okay. Yeah.
So I'll just go down here, blah 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 blah, blog post, blog post, blog post, and we'll.
DSA.
Yeah. Okay. Blog post tags. Many.
Keyword.
Yes. Okay. Perfect. And then maybe we can just add a function then that takes this keyword and creates the name.
Yes. I agree.
You want to have a go?
So where are the tests?
That test doesn't exist. We're going to have to create a new namespace for the tags.
I see.
Probably. Yes.
Let's see. So we have the source here. And let's make a tag.
Yeah.
Tags. Cool. Here's the test. I'll write the test then.
OK.
So it's
perfect.
Get tag.
Name or something?
Tag name?
Yeah.
Yeah. OK.
So you'll notice that by not creating a pull request, I can get my colleague to do the work for me. That's very clever.
Pretty clever.
Yeah.
So tag name, closure, and I expect that to be closure.
Yes, perfect.
Okay.
That seems reasonable.
Let's put an error exception on the page here. Yeah.
Boom.
No such thing.
No such thing. OK. So that's my job then. I'll just use this trick to create it, and I'll say tag ID. And name, tag, that's probably not enough. Do stir, capitalize.
Yeah.
Okay. Tests are green. I'll add another test. What about this one?
So,
Tests are failing, sir. Please fix.
so now you can see that they're failing because it's expected nats and it's really a nats with a lowercase ats.
Right.
So this is interesting because do we want to hard code tags here? It would be the simplest.
Yeah, sure. Why not?
In that case,
I mean, if it gets untenable, we could just fix it later.
so it's basically just this then.
That's not going to
Oh,
work.
oops. That's a function. But we can extract it and we can do special tag names. Okay?
Ah, perfect.
I will do something. Oh, I already had that. Something like this.
Perfect.
Are you happy?
I'm pretty happy. Actually, I think this is good enough for now. So I'll just commit this and yeah.
I'll go back then.
Thanks.
you.
Okay, so small applause to the gentleman helping me out. Okay, so I'll create 2 commits for this. The first one is just to add the ability to have tags. Ability to store tags. That's not going to hurt my production environment. It's just an added attribute. And the next one will be the function that formats the tag. So format tag names for display, which is also safe to do on main. Now this one I'm going to take away. But now, by setting aside a few minutes to pair program with my teammate, we have readily reviewed code. So we didn't have to go the loop with the pull request. Very good. Next, I'm gonna cheat a little bit and find a commit here that actually adds tags to all the posts. So you can see that this post here goes through all the posts and put tags on them. So that's going to allow me to do another small win. Once again, take a look at this. We wanted to say about and then the tags should be clickable so we can go to the tag page. Creating the tag page is obviously the biggest job here. But now I have tags in the data model, which means I can at least display them. I don't have to link them because they will lead up to nowhere, but I can display them. So let's do that. So I will then go in here, once again in the teaser, and then my blog post has tags. And I will add the body to the aside that we created before. Now, this is going to look weird because it needs to look up things from my I18N dictionary, since the site is both in Norwegian and English. But I'll look up the tags, pass in tags, and then map tag, get tag. What did it call that function? Nothing. Tags, get tag name. Okay, tags. So, and then we're going to go into the dictionary and add this key, tags. Span, about, and then I'm going to use a strange construct, which is called enumerate the tags. This will just display the tags with the comma in between and before the last one. And we'll add a Norwegian version as well. But it's like this. Goody, goody, goody. Now, boom. Let's do this. And now I can display tags. This is also useful to my users, so I can commit this and push it out. So hopefully you're catching on now, but very small increments all the time. Display tags on teasers. Cool. 7 commits already. In a talk. That's the first time for me, I think. Okay. So from this point, there's not a lot more I can do on this page. I'm going to have to start working on the tag page now. And that's a bigger piece of work. And I'm not going to bore you by taking you through all those steps. But I want to show you one more trick. Because let's imagine that I had already prepared this page. And you're not going to believe it, but Come on. If we go here, I can en closure, and then boom. Okay, so here's the page. I made it. But the tags are still not linked. Now, as long as those tags are not linked, there's no way to reach this page. So you could have developed that piecemeal also on the main branch and not have to worry because no one would find it. But now it's done, and I'm ready to connect it to the rest of the world. And this is where a technique, so Kent Beck has named this technique keystoning. It stems from when you build like stone arches or like an igloo or anything that kind of curves like this. When you place the final stone, that stabilizes the entire structure. That's effectively what I'm now ready to do, because this archway, if you will, is ready, and I will place the keystone by linking up the tags. So let's find, yeah, here it says prepare tags. Cool, so here I'm just returning the tag name. So I'll just wrap that in an A, href, and then hopefully there's a router here. I can do get tag URL, and it expects to get a locale, so we're gonna have to pass it that. Rum-pum-pum, page, okay. Page locale. I get a locale up here, locale, and then tag ID from the tag. And there we go. So now the feature is complete, right? So you'll notice that this final commit, which is the one that really has the big effect on production, is very tiny. It's just a small keystone. It just adds the link. So I'll commit that, and we'll say keystone the tag page into being. I wouldn't usually use such a pompous commit message, but it's just for fun right now. Right. So that's a useful technique. This works very well when you've developed a feature more or less in isolation, and you just need to hook it in one or a few places. Sometimes features are more spidery and connect in multiple places. Then you might need to use other tricks. So you could put a configuration setting in your app and make it only be available in development and not in production. That's a more hefty version of this technique. Or you could use any number of feature flags. And feature flags is really just a fancy word for an if in your code that checks some condition. People can sell you really, really sophisticated feature flag solutions. You're probably never going to need them. You could check just the existence of a query parameter, a username, or some data on the user, whatever. Remember, a feature flag is literally just an if for some condition that you can make up on the spot. So, okay, so all these examples so far have been about adding stuff to our code. It's very, I'm putting lots of stuff on the page that you can read, which is not a good strategy, but anyway. Okay, so all these are about adding stuff to our code base. But sometimes we do other things with our code base. We change it, we refactor it. How can I do that on main? Well, I actually just did, because when I was preparing this talk, I found out that our blog mostly just all lived in one namespace. And I didn't really want to show you that, but you can see that there are some formatting functions. Here are the blog post stuff. Here's the layout. Here's the front page. So all this stuff was just in one place. And I figured I want to split this out into different namespaces so it looks nice for the audience at NDC. So how would we go about doing that on main? Well, I'd say that a goal would be to get these functions put in like a blog post namespace. But these functions are calling this one and this one, so let's start here. So once again, work in really small increments, and we'll just grab this function here and the locale that it uses, cut it out, and create a new namespace. And I'll grab these imports, and now I can do another cool thing. Because my code is running, so I can evaluate it to make sure that this runs and compiles and works. And it does. And I'll change the name to format date here. And then we'll go back to the namespace where I took the function, find the call, and update it to use the new one. There we go. And then we'll clean up, and boom. I've moved one function. This is a complete piece of work because my tests are running and the thing is still working. Better stop now before I crash the entire thing and it no longer compiles, right? Because it's bound to happen. So I'll just commit this, extract, format, date, emd to new I18N name space. OK. And then I could continue. I could grab this function and move that and commit that. The good thing about this is if I end up in a situation where things are just completely broken, I can undo like 4 or 5 lines at a time and figure out where I went wrong. It's much easier to solve than if you were to blow up this entire namespace in one go and then try to figure out why it doesn't work anymore. So actually, let me see. I want to push this commit, so I'll just check. Oh, God damn it. So who's been working? Sorry. I knew it. So Magnus has been working here, and he's also been changing the same namespace that I changed. That's no good. So, OK, he's made some changes here. Fine. OK. Let's try to apply his commit. Ha! OK. So now I have a merge conflict because it turns out that Magnar has just changed the function that I also changed. But this is a relatively small merge conflict. And I can see that I made the change from here to here, and he has made some other changes. What would this have looked like if I had moved this function to a new file? I would have been shit out of luck. That's what would have happened. So by working in small increments, even when you get conflicts, they're easier to resolve. I'll show you one more example of this point. We'll just leave this. No one wants to watch merge conflicts. OK, here's another one. So I've started to internationalize the site. So it used to be just in Norwegian. Now it's in Norwegian and English. And part of that is to extract the texts from the code into an I18N dictionary. And that's what's going on here. So the front page, we've taken the texts out of the front page, blah, 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 and stuck them all in the dictionary. Here's my dictionary. OK, so that seems benign. Let's try to push this one then. Again? All right. So Magnar has been working again. And obviously, he has also been putting some stuff in the dictionary. And that doesn't bode well for me. Let's see what he did. This is another page he's been working on. And here are the texts. So let's try to apply this commit then. Another merge conflict! Damn it. OK. Why? Well, as you can see, or maybe not, it's impossible to read diff, so I'll just explain it to you. But we both added stuff to the end of the file. And it's the simplest thing to do, right? When you're coding and you want to add something, and it doesn't really relate tightly to anything else, we just put it at the end of the file. And because everyone does this, you frequently run into merge conflicts like this because everyone changed the end of the file. Could we have done this another way? Why, yes, I think so. So check this out. I'm going to abort this and have a new look at the dictionary here. Hello. OK, so this dictionary really just has, these are the layout texts and these are the front page texts. What if instead of just always adding to the bottom of the file, I would structure this file alphabetically? So front page comes before layout. This would also make it easier for me to find stuff in this file when it grows. So I'll just edit it alphabetically, and we'll try again. I just amend my commit. And now I'll try to merge the upstream changes. I don't believe it. Let's see. This was not supposed to happen. What's going on? Yeah. Yeah. I'm missing a space somehow. I told you I can't read this. I don't understand what this means. Okay, we'll have to abort this and try again. Aha, there we go. Pretend that didn't happen. Okay, now it applies cleanly because these things were alphabetically spread out. And this might seem a little bit fringe at first, but it's actually really useful in a lot of places. So take a look at this. I have, obviously I can no longer type. Here we go. So you typically have stuff like this, right? Dependencies. They can be ordered alphabetically. Here I have a bunch of cases. They could be ordered alphabetically. Many times you can put functions in the namespace in alphabetical order, but sometimes you may have to move things around because of dependency order and stuff like that. But when you can, consider not always just tucking new stuff at the bottom, because that's going to lead to merge conflicts. So I find this to be a really useful small tip. And with that, you will no longer have to watch me work. We're roughly done with that section. So I want to sum up like the two most important things that I hope you took away from this little process. Of course, other than that Clojure is an excellent language. So the first one is the work in smaller batches. Like always, keep narrowing in your focus and find the tiniest bits of work you can do. And like I said, this site is simple. Don't think that I could make it simple because the site was simple. This process always works. You can always break things down. And the other thing is what I like to call keeping the lights on. Make sure that the code compiles and runs and that your tests are at least able to run. If these things are not true, if your code stops compiling, how will you know whether what you're doing is for the better or for the worse? If I broke 3 tests and then I changed the code, it stopped compiling, I changed it some more, will it get better? Who knows? So that should be a priority to fix. And I'm not saying like I'm not perfect. My code stops compiling, not all the time, but occasionally. But then when that happens, that's the first priority. Get things back up running so you can use the runtime to get information about whether your work is getting you to a better place or to a worse place. And these two things together help you increase flow. And this is not just something that I say. Like people knew this in the 80s. So I very warmly recommend this book, The Goal. It's from 84 or something. It's it's written by a physicist, and it's about a factory. It's a novel. It doesn't sound all that exciting, but it's really interesting, and it really is about the same process of breaking things down into smaller batches and then see the flow and throughput of your system increase. And this book inspired another book that some of you may have heard of, which is called The Phoenix Project, which tells the same story set to an IT company and was written like 35 years later. But both of these books are really excellent and really hammer in the same point that I tried to show with my little working session right now. Yes, okay. One thing I did not discuss, or I just mentioned briefly, is what if you are doing stuff that cannot be on the main branch? Like you're going to make a huge upgrade to your framework that will break all the files in your project. Or you're going to redesign your site or some other huge change. Well, my first approach to that problem would be to don't have that problem. And that may sound like a joke, but it is actually not. So I stopped using frameworks with breaking changes many years ago, and I still have a job. So it's possible, but I mean, if you can't do that, well, then you're going to have to apply the smaller batches mindset to this problem as well, and try to break it into manageable chunks. But obviously, maybe you'll need to set aside some time for discovery first. Like just investigate, what do I need to do, then compile a list of stuff to do, so that the doing doesn't spread out over too much time. But with that said, if most people in your team work on the main branch at all times, it's okay to have the occasional feature branch for bigger changes. Because now your team is not, they're not all working in big changes on branches. So if everyone's like continuously integrating their changes, it's okay to have one big project at a time that you do on a branch. You just don't want to have too many of them, because that's when the problems start cropping up. And as for redesigns, they can be handled on main as well. You could create a new theme, keystone the theme in. You know, some redesigns are just basically a new version of a page. Build a new page, and then just switch it over when it's done. So, a lot of the times you can really break things down into smaller chunks. Yes, let's just a quick summary of what we learned, or hopefully learn. So first, it's the process ideals of working in small batches, keeping the lights on, like I said, continuous reviews. So I didn't mention this explicitly, but when I pulled down the commits, after I yelled at Magnar for disturbing my workflow, I also looked at his commit. If I saw something that I didn't agree with, I could just walk down and talk to him. And then we'll have like an impromptu small review. And when all the changes are like 5 lines, that's pretty easy to do. And the changes that aren't 5 lines, they will typically be developed during a pair programming session or a mob programming session or whatever. Work together instead of first making a sketch and then asking everyone else, do you think this thing I spent 40 hours on is a good idea? They're going to say, yeah. They're never going to say, hell no. And then we did a bunch of things. We added a new UI component that's completely safe to do on main. We added to the schema and to the data model. We added new data. We added new functions. We added new feature islands. All of these things are completely safe. Additive changes are typically backwards compatible and safe to do on the main branch. And then finally, we saw several examples of scoping down and shipping early. Use keystoning to attach features, and then I didn't show this, just told you, but you can use configuration and feature flags if you need to run broader experiments than I did. But typically, in my case at least for the past 10 to 15 years, keystoning has solved 95 of my problems. 95%. I have okay. All right. Anyway, that's the talk. If you want to discuss or whatever, I'll be around here, or you can find me on the conference floor. Don't hesitate chatting. So, thank you.
talk proper at about 1 minute past, because that means that anyone who comes in can't go, "Oh, but it's still 4:20 and you started and I'm late and I'm sad." So yeah, how is everyone doing? You've been having a good day so far at NDC? Yes. This is, I love NDC. This is my second NDC Oslo. It looks just as incredible as it did last year. I'm very excited to be back. Lots of cool sponsors, amazing food. I am going to spend the next 2 days standing by the poke bowl stand and just shoveling into my mouth, I think. And of course, amazing speakers. I'm very honored that anyone's come to my talk when there are so many other great speakers in the same slot. I hope to make it worth your while. We are coming up on 21 minutes past, at which point I will properly kick off. Right. Thank you all so much for being here. My name is Eli, and I am here to talk to you today about how we talk to each other. So this talk is about communication, and a lot of what we do as people who design and build and maintain software is communicating either with other people or directly with computers. Has anyone ever had the problem where you're reviewing a PR and one person is saying, "We could do this in a beautiful, elegant one-liner that's really unreadable," and somebody else is saying, "Actually, we could split this out into a multi-line statement and it would be a lot more readable, but it wouldn't be as neat, or it wouldn't be sort of as satisfying." So does that sound familiar to anyone? Like a couple of hands, yeah. Has anyone ever been in the situation where a requirement has come in from a product owner that makes complete sense for the real world and the problems that your software is solving, but would mean that you had to rewrite your software from scratch? Something like, we need our users to be able to change their email address, but you use the email address as the primary key. Does that sound familiar? So both of these are examples of miscommunication, or they are problems that relate to communication. And as we go through this talk, I'll explain why. And I'm going to take you through some rigorous frameworks from some philosophers from history that can teach us a little bit about how to think about communication and how to get better at it. So here's what I think is happening when people communicate with each other. Here are two people, without loss of generality, me and you. And I have an idea in my head. I want to convey this idea to you. So I say something or do something. I make some gestures, or I write some words using a keyboard or pen and paper, or I say something. As a result of this action that I've taken, you perceive something. You hear the words I speak, read the words I write, or see the gesture that I've made. And as a result of your perception of this action, you get an idea in your head. And this is the basic model that I'm going to use to illustrate the ideas throughout this talk. Of course, it can get far more complicated than this, right? We could, in the middle of this flow, turn those words or those actions or those gestures into something that gets encoded digitally and sent over the internet or written down on paper. And there's all sorts of errors of transmission that can happen in that stage. But for now, we'll focus on this sort of more basic case. One of the things I like about this model is that it makes it very clear that in between the part where I have an idea and the part where I say something, there's a translation layer here. The pink light bulb and the pink gesture, they're not the same thing. So there's for every person, there's this sort of internal translation layer that lets us know how to turn ideas, concepts, into gestures of communication, right? There are multiple ways, perhaps, to express one concept. This is something I learned when I was doing maths tutoring during my degree. I was trying to explain logarithms to a student about 17 or 18 years old. And the way that I conceived of them, that they made sense in my brain, I couldn't find a way to convey that so that she could have that light bulb moment. I had to try lots of different ways to express this concept. Similarly, you might have one way of expressing something that could have multiple meanings. The word run in English has something like over 600 dictionary definitions. I'm going for a run. I'm running software. My nose is running, you know? So we've got these ideas, and we have things that we use to express ideas. And this is a many-to-many relationship. This means that communication is really hard and confusing. So how can we understand the relationship between these two things? It's time for us to meet our first philosopher of the day. This is Ferdinand de Saussure. and he was basically one of the founders of modern linguistics. Do we have any people who are really into linguistics in the room? Yeah, a handful, cool. Going to be talking about linguists today. Ferdinand Saussure, the thing that he did that we're particularly interested in today was that he basically founded the modern field of semiotics, one of the two major founders of semiotics. He called it semiology, we now call it semiotics. It means the study of signs. And signs might make you think of road signs, visual signs, but in the world of semiotics, a sign is anything that is used as a tool of communication, anything that is used in order to communicate. Words are signs. Gestures such as like this for I love you in British Sign Language, that's a sign as well. And the thing that Saussure said that was kind of groundbreaking for his time was he said, okay, a sign has two components, and they are the light bulb and the gesture, right? He said, okay, we've got something that lives in our heads, and when we use a sign to try and convey it, this is the thing that's being signified. And when we do something to try and signify an idea, that's called a signifier. Now, in the interest of me not fumbling my words and having a better chance of the two light bulbs in our heads matching as closely as possible, I'm not going to say signified, I'm going to say concept. So we've got concepts and we have signifiers, and we use signifiers to try and communicate concepts. And Saussure said something that was groundbreaking for his time. He said that these two things don't intrinsically have to have anything to do with each other. People thought at the time that the words we used were somehow a sort of metaphysical reflection, expression of the concepts that they referred to. But that's not true, and I can give you an example to show. Here's an animal, and in Egyptian, this animal is called a mao. And if you've ever met one of these animals, you'll probably understand why. But in English, it's a cat. Why? I don't actually know. I don't know the etymology of the word, but on the face of it, there's no reason that this sequence of sounds should refer to this animal. But it does. We all understand that it does. The sign, cat, and the concept, that animal, are two different things, but we understand that they're connected. So when we come back to this model where you've got ideas in your head and things that you say, things that you perceive, and we come back to the idea that we've got this translation layer that lets us translate between concepts and signifiers, and that forms the basis of our ability to communicate. Another thing I like about this model is that it makes it clear that the ideas in the people's heads, right? The pink idea that I have in my head, the contents of this talk, and the blue light bulb that you have in your heads at the end of this talk, they aren't the same thing. They can't even be directly compared because of those internal translation layers. All we have are best guesses and attempts to signify what we mean through these potentially imprecise signifiers. These two things are not the same, and we can never know if they're the same. Is the blue sky that you see the same blue sky that I see? So we have concepts and signifiers, and our ability to link between these two gives us the ability to communicate concepts between my head and your head. How can we understand the relationship between them? This forms the basis of our ability to communicate. Well, Saussure had an answer for this too. He said that when somebody speaks, when somebody communicates, it goes like this. There's a person with an idea in their head, and as a result of trying to communicate that idea, they say something or do something. Familiar so far, right? He called this parole, an act of speech. He was French, these are French words, parole. And the person knows how to make that act of speech to try and communicate because they have an understanding of something he called langue. And this is what linguists study, right? This is the shared understanding of language, of a human language, for without loss of generality, that allows us to make that translation between concept and signifier. And we all share this understanding, but it is also entirely constructed and lives entirely within our collective heads. And this is really interesting to linguists because how does this thing grow? Well, what Saussure said, and again, this was groundbreaking for his time, he said that acts of speech actually contribute back to the overarching language, right? We know this to be true because we have, slang. And when you use a word to mean something, if you gain critical mass within the speakers of that language, it becomes an accepted part of that language, and it becomes a way that somebody can communicate a concept. And Saussure called this a speech circuit. So when we think about language and being able to translate between concepts and signifiers, we have to think about this thing, the langue. We have to understand, where does this come from? How do we know how to use it? And this is what leads us on to meeting our second philosopher of the day. This is Ludwig Wittgenstein. Any Wittgenstein fans in the audience? Yep, a couple. To me, he was the philosopher. He did everything, like maths, ethics, logic, language in particular. One of the most influential philosophers of all time, according to a lot of people. I like a lot of what he said. And one of the things that he did that we care about in particular today is that he came up with the concept of language games, for which this talk is named. And what Wittgenstein said was that language is a game like games of skill or chance or athleticism. And language has rules. And every time you make an act of speech, parole, you can be understood to be making a move as part of the game of language. And that when people share an understanding of the rules of the game, they are able to play together, which is using language to participate and using language to communicate. So the other thing that matters, and again, this was groundbreaking for his time, is he said that in different games, different rules can apply. The rules of a language game give us the means to translate those concepts in our head into signifiers that other people can perceive. It's a pretty abstract concept, and he mostly used analogy to try and explain it rather than give a direct explanation. So I will do the same. Let's say we have two attendees of this conference. Let's call them Tibbs and Espen, and they're building some Lego together, right? And they have a Lego set that is comprised of a bunch of 3 different kinds of Lego elements shown on the screen above. And Tibbs is building, and Espen is handing Tibbs pieces. And Tibbs says, brick. And Espen hands them one of these pieces. And then Tibbs says, plate. And Espen hands them one of these pieces. Then Tibbs says, jumper. And Espen hands them one of these pieces. They're playing a very basic language game in which the word jumper means hand me one, and exactly one of that style of Lego element. Now, it's worth noting that the rules of this language game are inefficient. Pink, the color, has 1 fewer syllable than jumper. Pink, white, and blue would have been more efficient ways of communicating the same information, right? But Tibbs and Espen are both big Lego nerds, and they want to use the official Lego terminology to describe the elements that they're talking about. Language games aren't necessarily, especially with natural human language, aren't always the most optimal, the most efficient. There's human quirks in there. So we understand that language is a game, and it has rules, and that if we understand the rules to be the same thing, we can play a game together, and that will be communication. So if language has rules, what does it look like when we break the rules? Here's a sentence, and I'll give you a moment to look at it. Can anyone tell me what this means? It doesn't mean anything. This is an example of something that's called a comparative illusion. And it's a bit like the linguistic equivalent of one of those Escher staircases that loops back around on itself because of the perspective. Each part of this sentence looks like perfectly fine English, but when you look at it as a whole, it doesn't mean anything. There is technically a grammar error in here, and it's to do with the fact that you're comparing a number, more people, to a bool, a truth value. Have I been to Berlin? But it's a very subtle grammar error, and it's one that most native English speakers wouldn't know how to describe. I certainly didn't until I looked at the Wikipedia page for this. So this is an example of breaking the rules of the English language, and what it results in is something that doesn't communicate any information. It's a failure of communication. Here's another sentence. Does anyone want to tell me what this one means? I have a pointy baby. She's a cat. I have a cat. This means I need to trim my cat's claws. I say this all the time in my household. She's the baby. She's an indoor cat. She isn't wearing down her claws on concrete or anything. So sometimes her claws get long. She becomes sharp. So we need to unsharpen her. So we need to unsharpen the baby. And like this Berlin sentence, this might not seem to make sense. But in the context of my household, it does, because like with any game of skill or athleticism or chance, you have your basic rules, the rules of English, and you can also have house rules, additional rules that go on above and beyond the basic rules and allow you to make different kinds of moves that make sense for your context. And this is the thing that Wittgenstein really was trying to get at with his idea of language games. And I think it's very similar to what Saussure was saying. Context sets the rules for a language game. Language only makes sense in context. So, for example, the word water could mean a lot of different things. It could mean, I am absolutely dying of thirst, please let me take a drink. It could mean you're cycling and somebody's about to go into a pond. It could mean any manner of things. It could be somebody, expressing why they didn't like Generation 3 of Pokemon. Too much water. 7 out of 10 or whatever it was. Context is the thing that gives language meaning. And like with Saussure's ideas that the signifier and the concept didn't have to be related, this was pretty controversial and groundbreaking for his time. People thought, they didn't really have this idea that different things meant things and different things in context. There was, again, this kind of idea of words and language having some sort of metaphysical, real meaning that wasn't just simply contextual. But Wittgenstein says, no, it is all contextual. And the more context we share with somebody, the better we're able to communicate. The less context we share with somebody, the less likely it is that we're going to have a lot of rules in common and be able to use those rules. Our language games are going to be much more limited. So what does it look like if we have to communicate with people with whom we share very little context? There are some people whose entire job is to figure this out. Does anyone recognize this sentence? Yep, Tibbs is getting it all, and you as well. So there are some people, one of the things that humanity does is we build things and we do science and we make things. And we've caused lots and lots of problems for ourselves with this over the course of human civilization. And one of the problems that we've caused is nuclear waste. Nuclear power, good, great, actually, but it does result in waste that is dangerous now and will continue to be dangerous for 10, 20,000 of years. The half-life of some of these waste products is that long. And when we think about 10 or 20,000 years, that is longer than any one human civilization has lasted. Human languages come and go much, much faster than that. They evolve, they die out, so on and so forth. And there is an institute for this long-term storage of nuclear waste, and they have a mandate to try and figure out, if we bury some nuclear waste, how can we prevent people in 15,000 years' time from going to dig it up? Because it will still be harmful to them. And what they've come up with a lot of stuff, but the most famous of them is this series of messages that are meant to embody the sort of, these are meant to represent concepts, and we have to try and find signifiers that are going to make sense to people in the future. And the concepts range from very general, and then they start becoming more and more specific. So these are some of them. What is here is dangerous and repulsive to us. This message is a warning about danger. These messages are some of the most metal stuff. It's so cool. The danger is in a particular location. It increases towards a center. The center of danger is here, of a particular size and shape and below us. The danger is to the body, and it can kill. The form of the danger is an emanation of energy. And you can see that we're going from sort of more broad, general, generic things down to more specific, like talking about where it is and what it is. So we're going from ideas that are easier to convey because they require less context to more specific. Because the more specific an idea is, the more context you need in order to share it. This is a sign that this institute has come up with. It is called ISO 21482-2007, made in 2007. And the idea is that this sign will be displayed at any nuclear waste storage sites. And if you look at each individual element, there's sort of three things going on in this picture. We can look at each element and see why or why not it might be effective as a method of communication. So one of the things we can assume about people in about 10 to 20,000 years' time is that they will look quite similar to us, broadly. That's not enough time to evolve more legs or anything. I mean, I guess depending on how close you are to the nuclear waste. But we can broadly assume that people will look quite similar to us. So if you think about a skull, generally, human civilizations have buried their dead, pretty much like some of the earliest sort of records that we have and remains that we have show that people have been burying their dead for a long, long time. So you don't see a skull unless something's gone very, very wrong. This is something we can probably assume to still have a universal meaning of bad. Something's bad here. You do not want to be here, you do not want to see a skull, this is bad. We can also assume, again, that people are going to look quite similar to us. So these symbols are fairly likely to still be interpreted as like, a person in motion, This one is the one that's really difficult because nuclear radiation, ionizing radiation, is a really difficult concept to convey. I mean, honestly, even to someone without a physics background, you try and convey that, like, what is nuclear radiation? Is it real? How can you tell if it's around you to somebody who hasn't got sort of up until about 16 years old been learning physics? That's really hard. And then when we try and think about conveying it to people 15,000 years in the future, we have no idea if they'll even have an idea of what this concept is. So this one, I think, has the highest chance of not being parsed by the audience in the way that it's meant to, but I think that's an intrinsic difficulty. And on the theme of things used to convey meaning, potentially having multiple meanings, this sign could mean danger is here, ionizing radiation is here, leave, there is danger. But it could also mean when snakes come out of the ceiling fan, run away from the pirates. And that's something that I really want to try and get across, is that when we communicate with other people, all we have are best guesses. We can never actually be completely certain, like logically certain, that we have successfully communicated a concept. We can't compare the blue and the pink light bulbs directly. We can't know that we have communicated adequately. That's scary. Communication is hard. Right, with that in mind, we come back to this model of people trying to communicate concepts with each other. And this is well and good, and this is something that we have to do in our job as software developers. But part of our job is also talking to computers. When we think about the idea of talking to a computer, a lot of the concepts that I've just been talking about don't seem to apply. I mean, a computer has no interiority. It doesn't have concepts and signifiers and so on. It takes input and it executes on that input. So what does it mean to talk to a computer? Well, we build language. We start with machine code and we add layers of abstraction and syntactic sugar until we get to something that can reasonably be called a language. We teach the machine what open curly braces and if and when mean. A programming language is the set of rules for a language game that we play with a computer. That follows pretty naturally, and I think it's really cool. But above and beyond that, what we do as engineers who write software in programming languages is building up house rules that we play with our computer. Like how in my household I can talk about unsharpening babies. Within your software, you can talk about specific concepts using language that you've chosen to convey concepts to your computer in a way that makes sense for your context. Writing software adds rules to the language game that you play with your computer. It allows you to communicate more efficiently without repeating yourself as much. So when we write code, this is what's going on. One person alone at their computer writing some code, building up a language game that they play with their computer in order to communicate things that they want done. And this side of the equation is pretty much a solved problem. If I'm writing Python code and I know that it's in CPython, I can actually look at what that code compiles to. I can go all the way down the stack and see actually what is being executed on my machine. And this side of the equation is get better at writing code. Do your HackerRank, your leak code, your code cutters, all of that stuff. Just get good. One thing that I do want to briefly mention, and my one mention of AI in this talk, is that when you do prompt engineering, it's qualitatively different than coding because you've added a black box back into this side of the equation, right? I can't write something into ChatGPT and follow the chain of execution all the way down the stack like I can with writing C-Python. So that, I think, is something that's genuinely qualitatively different about prompt engineering versus coding. Really interesting. I'm making no moral, I don't think that's a good or a bad thing. I think it's cool, I think it's interesting. And not many people are talking about it that much. But anyway, we come back to this scenario. And this is what happens when you write code, right? But when you're a software engineer, what actually happens is this. There's you, and you have an idea of what you want the computer to do, and you write some code, and that executes on the computer. But there's also the rest of your team who are all doing the same thing. And when you work on a team, you have things like meetings, and Jira tickets, and documentation, and water cooler chat. And these are all methods of communication with other people where things I've been talking about very obviously apply, like, language games and so on and so forth. But that's not the only way that we communicate with other people on our team. The path up top, that is also a channel of communication. When we write code, we are communicating with other people on our team as well as the computer. My good friend David Whitney has a talk where he has a quote where it's code is literature that is also executable by a machine. Primarily, code is going to be read more than it is written. And when we write code, we need to be mindful that we're not just building up language games with a computer, but we're building them in order to be used by other people as well. And this is where a lot of clean code stuff comes in. And what happens when you're on a software team and you're trying to work together to solve a common problem as efficiently and as clearly as possible? Is something that's actually been studied by our third linguist of the day. I mean, not directly, but he studied very similar things, or our third philosopher. And this is someone called Paul Grice. He was a British philosopher of language. And what he studied, one of the many things he studied, were systems where people were earnestly, in good faith, trying to communicate with each other in order to reach a common goal. And he described what he saw there as the cooperative principle. He noticed 4 trends, four themes coming up again and again in these kinds of communications. And these are things that he noticed, but he also phrased them as imperatives, like you should do this. But it's worth noting that these are things that he noticed coming up organically again and again. And there were 4 of them. Grice's maxims is also how they're known, and they are these. The maxim of quantity. He noticed that in cooperative communication systems, people are often, they need to be as informative as required, but no more. Don't info dump, but don't leave things out. So, if someone asks you for a specific piece of information, give them that specific piece of information, but you don't necessarily need to include wider context. The maxim of truth. People are truthful when they're communicating cooperatively. This is why a lot of communication that people do is not necessarily cooperative. I mean, we lie, of course, but we also tell jokes where a lot of humor relies on leading somebody to make an assumption by potentially omitting information and violating the maxim of quantity, and then subverting that expectation, or outright telling lies for humorous effect or something. So jokes and deception are not part of this system. They're not examples of communication that's cooperative. But when you're communicating cooperatively, you should be truthful. There are caveats to this. As I've said, I can never truly know what's in another person's head, but if somebody has told me that they have an opinion, it's fair for me to treat that as something that I know. The maxim of relevance, obviously quite related to the maxim of quantity, but let's say that we've got Tibbs and Espen who are playing their game with Lego, and Tibbs says jumper, and Espen hands them both a jumper and a brick. The brick isn't relevant. It's violated the rules of the language game, and it's also violated this Grice's maxim. So if somebody has asked you something, you tell them the answer to that question, but you don't include information that isn't relevant. It's inefficient. And the last one is the one that I think is really interesting, because it's the maxim of clarity, and this is the one that involves empathy, because it's about framing your communications in a way that is most likely to be comprehensible to the person with whom you're speaking. It's about using words that are going to be easy to understand, I know that, I mean, I'm a native English speaker. I use a lot of thesaurus words. I really do try to make sure that when I use thesaurus words, I'm using them because they are the correct, most specific word for that situation and not just to make myself sound smart. The maxim of clarity is the most nebulous one of all of these, and it's the hardest to tell when it's being broken. And there's one of the things I love about this is I mentioned that he framed all of these, as well as sort of these maxims, he gave imperative names to them. So maxim of quantity, be informative. The maxim of truth, be truthful. Maxim of relevance, be relevant. But for the maxim of clarity, he didn't say be clear. He said be perspicuous. Has anyone ever heard that word before? Tibbs has had it again. I hadn't before I did the research for this talk. I knew there were the 4 maxims, I knew what they were, but I didn't know that was how he phrased it. What a beautiful violation of the exact maxim he's talking about. Be perspicuous. It means to be something that's able to be seen through, something that's literally clear, something that you can see right through it, you can comprehend it. I believe perspex, the kind of clear glass type thing, comes from the same root. So if you're ever in an icebreaker type thing and you don't know what to say about yourself, just say, I'm perspicuous. Ridiculous word. So we have these maxims that Grice identified, these trends that Grice identified as being hallmarks of good cooperative communication. And this is a talk about tech, so I'm going to talk about how these can each relate to code. We get a lot of clean code stuff directly from these if we want to look at it that way. The maxim of quantity is things like making sure that all your data is present in your code, but you're not including extraneous data in data structures that you use. Maxim of truth, check your assumptions, make sure that the data you think is there is actually there, and do good testing and so on. The maxim of relevance, factor out functions into things that do one thing well and don't have big mega functions with lots and lots of stuff going on, lots of stuff that's not relevant to everything that's going on in that function. But the really interesting one to me here, when we talk about code and writing software, is the maxim of clarity. What does it mean to communicate clearly and use the right words for a situation when we write software? Well, we should be thinking about what it is that we're trying to communicate to the computer. And when we're writing software, usually what we're doing is we're trying to communicate some kind of real-world problem to the computer. We have users and we want to solve problems for them. And we need to model that real world in order to get the computer to do work on it. So if we're being clear with the computer, what we really should be doing is as accurately as possible, modeling the real world and building our language with the computer, our software, in order to describe that real world accurately. And that's domain-driven design. That's straight up just what domain-driven design is. So when we're on a software team and we're using domain-driven design and we're describing the actual world as accurately as we can, and we've got our Jira tickets and our Kanban boards and our sprint planning and our meetings, and we're all working beautifully asynchronously because this is the future, this is also getting towards a solved problem, more or less. Obviously there are still difficulties, but actually, as a profession, as an industry, we are maturing to a point where working in teams is something that's understood, and we have good frameworks for it. But I've lied to you again, because this is not actually what's happening when we build software, right? What's happening when you build software as part of a company is that you have stakeholders, and they are the people who pay your bills and tell you what problems you are trying to solve with the computer. And they do this, they say, here is what we're going to build. Here are the requirements for our project, and here's the problem that we're going to try and solve with it. And this can be in the form of talking to product owners, this can be in the form of OKRs, and so on. And those turn into actionable things for you as a developer. They turn into Jira tickets, they turn into epics, and so on. And those let you know what it is that you need to communicate to the computer. So you try and do that. And here, developers is standing in for the whole team. It's not just one person. And this is really what's happening when we build software as part of a company. Right? This is the flow of information. And at every stage, we've got concepts and signifiers and fuzziness going on. And the more we can eliminate that fuzziness by really pinning down what we're talking about, making sure that the rules of the language game we're all playing are actually the same thing. When your stakeholder says user, Do they mean person? Do they mean account? Do they mean email address? When they say payment, do they mean a payment that can be refunded? Do they mean a single transaction, something that can be reversed or not? You know, what ideas do your stakeholders have about the world? Because once you know what those ideas are, you're going to be much better able to communicate them to the computer. Build up a language with all your house rules, because that's what software is, that will let you talk to the computer about what is going on in the real world. You want your abstractions to be neat and really try and match reality as much as possible. Because this is what's really happening when we build software. But what stakeholders think is happening is this. Your stakeholder has a company, let's say it's the CEO, and they say they have an idea in their head, and they say something, and then software appears. And we as developers, as product owners, as architects, as designers, testers, maintainers, we're just an implementation detail. And our work that lives within this little bubble is everything I've just been talking about. It's the work of taking those real-world problems as our stakeholders understand them and turning them into something that the computer can understand, building up a set of language with which we can talk to our computer and tell it, hey, we need users to be able to change their email address. Because if what your computer understands by user is something that can't possibly have to have its email address changed, then you won't be able to communicate it. When I first gave this talk, it was in Porto. And do we have any Portuguese speakers here? We do, yes! Every time I've said that, that's been one, and I'm so grateful. So the word I used to illustrate this point was saudade. Would you like to give me a translation? Yeah? So my understanding of this word, it's sort of a famous untranslatable word in Portuguese, and it's called, the word is saudade. And my understanding of this word is that it refers to a bittersweet longing of wives whose husbands were out pioneering during the age of sail, or the bittersweet longing of Portuguese people who had gone to Brazil, left behind everything they'd ever known for something new and brave and unknown, a chance at a better life, knowing that they would never again see something with which they were familiar with from back home. And this is often called untranslatable because it relies on a very specific cultural context, and as we know, context gives language meaning. When you have the problem where your stakeholder has said, we need to do this, and you have to rewrite your software from scratch, you have to get rid of all of your house rules and go back to the basics of your framework or your language, that is when you have an untranslatable concept, because your context is not the same, because you've not built the rules of your language game to accommodate that move. So that's why that problem is a failure of communication. And that's the kind of failure of communication that frameworks like ideologies like domain-driven design are aiming to address. Yeah, domain-driven design, it's cool. There's lots of concepts in there that I think will become a lot easier to understand if you're new to it. Having seen this talk, one of the things that gets talked about a lot is the idea of ubiquitous language, which sounds so obvious now, right? The idea that you should have a shared language between you and your stakeholders so that when they say user, you know that what your computer understands by user is actually the same thing, and you're not going to have problems with untranslatable concepts. So, we're getting towards the end of this talk, but I'd like to wrap up with a few thoughts. What this all means in the world of sort of building software is that it's really good to reuse context. If we reuse context, we can make sure that our language means the same thing, because context is what gives language meaning. We want to all be playing the same language game, our stakeholders and our computers. We don't want to have to be doing a lot of work to translate and referee 2 games at once. We want everybody to be playing together so that all our lives are easier. Exactly, spending effort translating. If we can make it so that essentially we get to the point where our stakeholders are saying things, we can turn around and just kind of say that directly to the computer, our lives are going to be so much easier and we can all have more time to go home and play Baldur's Gate 3 or something. Now, this is where the idea of having stakeholders write behavioral tests in language like Gherkin comes from. The idea that your stakeholders, the way that they see the world should be what your computer understands as well. We want our signifiers to match our concepts. We want to make sure that that fuzzy translation layer in each person's head, the loss of nuance and the risk of miscommunication is minimized by really drilling down and saying, okay, what do you mean when you say user? Because I know that that's the signifier that you're using, but what is the concept in your head? Get them to describe it in multiple ways so that you have more chance of understanding what it is they really mean. And you can avoid problems that arise from that lack of understanding. Conclusions. Computers are awesome. We can communicate with them in ways that we can't communicate with people. What I meant when I said computers have no interiority, in contrast to humans, where the pink light bulb and the blue light bulb you can never really know. If you've got code that fits in your head, and you manage to communicate it correctly, adequately to the computer, you can know for a fact that you succeeded in that communication. That feeling of, yes, it works, even if what you're doing is just writing FizzBuzz in a new language. That's an incredible feeling, and it's something you can never quite have with another person because of that lack of ability to compare what's in your heads. I think that's why a lot of us who have struggled with communication in the past, and I certainly have, I'm great at communication now, I've got a system. But I think that's why a lot of us are drawn to computing, is because of that sort of certainty, that ability to define the way that you communicate with another entity, even if it doesn't have interiority. Communication is intrinsically hard. There's no surprise that it's one of the hardest problems we have. Intrinsically, philosophically, it's difficult, and I think we should all be proud of ourselves for managing to do it at all. Also, extra pat on the back for people who are listening to me speak quickly in English, whose first language is not English, which I appreciate is probably most of you. Communication is really, really hard, and we shouldn't be tough on ourselves for finding it hard, because it is. However, we can get better at it. Trying to understand what somebody really means when they use words to try and signify a concept, understanding what somebody else's context may be so you can understand what rules they're playing by when they use language, can make you much more effective as a communicator and as somebody who understands what other people are saying. This will impact your life in any time you have to talk to another person, which is a lot of your time, especially in a profession where a lot of what we're doing is communicating about the problems we're trying to solve with software, putting them on the computer, which is a form of building language, but also in your personal life. It makes it easier just to talk to other people in general. It's one of the things which is, it's really difficult, but it's one of the most rewarding things I think you can do. Thank you so much for coming with me on this journey through philosophy and linguistics. On the screen right now is a little QR code where you can give me feedback if you would like. It's completely anonymous, it's just a free text field. We have time for questions, but otherwise please feel free to go and grab some coffee, grab some food. I know we'll be at the Pokeball stand before long. Thank you very much for your time and attention.
All right. Hi, everyone. Thank you for coming to my session. I know everybody's tired. It was a long day. I hope everybody learned something new today. And I'm going to cover the Azure Cosmos DB with you today. I'm going to try to share some of the tips and tricks I learned from the projects I worked on. So our agenda is going to be, we are going to start with the physical partitions. We are going to move to the connection types. We are going to look at the SDK types and some of the tips I can give you out there. There's a caching option. It might be useful for you, and it might actually save you a lot of money if you are reading the same data again and again. And we will end the session with the indexing. Since Cosmos DB is a database at the end, we are going to check out the indexing too. So before I start, I guess let me speak about myself. My name is Hassan Savran, and I am from United States. I live in Cleveland, Ohio. And I'm a data platform MVP. That's my 6 years, and I'm proud and very happy to be a member of the group. I'm the developer for the Cosmos DB, the SQL Studio. I hope some of you actually using it out there. I'm the only developer out there right now. But we have a good number of users, and if you have any kind of feedback, please let me know later. I'll be more than happy to kind of share. If we will have time at the end, I can maybe demo that for you. Rather than that, if you will have any questions later, please follow me from the LinkedIn or the Twitter, or X, I guess now. I will be more than happy to answer any of your questions out there later. So let's talk about the physical partition. Well, when we say physical partition, really, it's the Cosmos DB server. And I guess physical partition is a fancy name. So we have logical partitions, which you have some rights to change. In physical partition, there's not that much you can really do. But it's important to know these two numbers you see here. So Cosmos DB, I'm really kind of comparing that to maybe like a restaurant here. So when you open like one server, it's like almost like you open your restaurant. And it gives you two numbers. One is the 50 gig, that's the storage limit that one server can actually handle. And also 10,000 request units, that is the horsepower that actually it can give you per second. So in here, when you start to actually have more traffic and more storage, for example, if you're going to start to get close to the 50 gig data here, or you're going to have a web application which is very busy, you're going to get close to 10,000. Rather than like a SQL server, which you might need to create maybe another floor on your current restaurant or try to make it bigger, well, Cosmos DB works the different way. So in Cosmos DB, it franchises it. So you start to open different restaurants in other places. So that's how you don't have any limits with the storage or the horsepower, because if you need it, it will give you another restaurant or another server somewhere else. So that is pretty important to know, because the data you see here in the different kind of data servers are not replicated data. That is distributed data. In other case, each of them has different data. So it's very important for you to kind of know where the data is, so you can send that request to only one server, not all the servers you have. So that is pretty important. So let's actually look at one example here. Let's say we are saving orders, and we pick the customer ID as our partition key, and looks like we have 202 gig of data. So, and also we have the 10,000 request units. So now, by just looking at the numbers, you can easily create a diagram. We have 202 gig, so we are kind of handling like 5 servers here. Also, we know the 10,000 request units, that's what we are paying for. That means that 10,000 is going to get divided by the number of servers you have. So that's really, we can kind of create this diagram without knowing anything else by just knowing those two numbers, 50 gig and 10,000 per server. Also, it looks like we did a good job balancing the storage, because the storage per server looks very similar to each other, and customer ID looks like that's a great partition key. And 10,000 request units per second is giving us 500 query, like all the numbers you see out there per second. So that's pretty busy application. And most of the queries we have looks like using the customer ID. So it looks like our developer was learning a lot about the partition keys, so they did a good job. So probably the developer is feeling really good in this case. Manager should be happy, and everything is working fine. Unfortunately, that's not the only, I guess, the problem you might have. So you might be in this case, everything might be working fine, and you might say that, okay, let's try to use the Cosmos DB a little bit more, maybe for different projects. Maybe we have the orders container right now. A new project comes up, and right now, as you can see, you need the customer ID. Everything is coming up with the customer ID. Maybe you want to see all the products per order. That means you are going to have another kind of project coming up, and we are going to use the product ID rather than the customer ID. So in that case, we have a problem here, because whenever we start to actually run this query in the same container, what's going to actually happen here is we are going to be in trouble with this project and the other project, because, well, we are not using the right partition key for the orders collection. Then this is going to start to actually cost a lot of money, and probably developer who created this one. Now, if you do this in, for example, SQL Server, you can just put an index on the customer ID. It might give you an okay, performance. But in here, you are in trouble because you are using a collection here which is actually developed specifically for the orders. So when this happens, when you get the bill, you're going to probably, surprised about it, because there's a lot going on here. And probably this actually broke the other project I showed you before. Well, because probably you don't have enough request units for the orders to write, and you might need to kind of change your request units threshold to a higher number here. So what do we do here? That's one of the most, I guess, the questions I get and most problems happens usually. We have the change feed function in Cosmos DB. In our case, what we are going to actually do here is, so we already have the orders collection. Our partition key is the customer ID. So that one is working fine. The one that we are having problem is the different partition key, which is the product ID. So in this case, what we are going to do, we are going to create another collection. Let's call that orders under product. So all we need to do here is we need to sync the data. We are really duplicating the data in two places here. And depending what we are going to try to do, we can go and hit the orders collection and get our data, or we go and get the data from the orders underscore product. And change feed is going to be able to duplicate our data automatically here. So the change feed is very close to the CDC in SQL Server, if you are familiar with that. Whenever data changes, change feed tracks that, and change feed is available in the NoSQL API, Cassandra API, Mongo API, and Gremlin API. You can actually get these changes in many ways. I prefer the Azure function because it's already on cloud, Azure Cosmos DB in cloud, so it's much easier to set up with the Azure function. But if you want, you can write an SDK, and you can do that with your own code if you like. So whenever data is going to change, in our case, a new order is going to come in, and Azure function is going to get triggered. In that case, right now, you have the order ID, so you can actually get all the information and take that information and do anything you like. In our case, we are going to duplicate that data in a different collection. So in our case, but don't forget we have that insert charge out there, so that's not going to be free. That insert, every time you're going to order something that orders under product, that's going to be an insert charge. So you kind of need to plan for that, or it can be a surprise for later. So in our case, if we have the customer ID, we are going to go and hit the orders. And if we have the product ID, we are going to go and hit the orders under product. This might be the cheapest way to fix this problem, because we are just creating a view in here, really, and you are fixing the problem by storage. And in cloud, storage is much cheaper. So if you can fix the problem with the cheaper in here, that will be the best way to handle this problem. Also, we have a point read function in Cosmos DB. Point read is the fastest and cheapest way to read data. You can read the data by point read or query. When you read the data by the query, you are actually running an execution plan. That's why when you look at the RU charge here, it's almost like 3 times more than point read. But point read, you must have the partition key and the document ID for it to work. In the query, it's highly recommended to have the partition key, but you don't have to. And you don't have to do anything with the ID. So if you have a 1 kilobyte data model, that will cost you 1 RU with point read, and it will cost at least 2.3 or more in the query. So whenever you are architecting your project, you want to be sure that even you don't use it, you want to be sure that you have the partition key and ID available in somewhere. Maybe you hide it somewhere under the web application. Maybe you have a grid out there, and you can just hide partition key and include ID in under each row. When somebody clicks on that, you can easily go and actually trigger the point read rather than the query. That will make things much cheaper and affordable in Cosmos DB. So the only, I guess you don't see the point read that much because there's no way to run the point read in Azure Portal right now. So you can run the query from anywhere, but the point read, you have to run that from the SDK. So that's why you don't probably see it that much, but it's available out there, and you can do that as long as you have the partition key and include ID is available. Next, we are going to look at the connections. So there are many different ways to actually connect Cosmos DB. The most basic one and most common one is the gateway mode. Gateway mode is available in SDK 2 and 3, and it's default connection for the SDK 2. So we really like, there's a server between your application and the Cosmos DB, and that creates like a one network hub, but it makes things a little bit easier, especially if you have like firewall, strict firewall rules. You don't need to worry about trying to open the IP range or the ports here, because everything in the gateway mode, as you can see, it uses the HTTPS and DNS endpoint, so it should be pretty easy to call and get the data in this way without kind of going to your IT department and try to, change the IP addresses or the firewall settings. So there are a couple of things that you need to know here. First of all, that server is free, but because of that, you share that server with other Azure Cosmos DB customers. Cosmos DB is available to kind of figure out who's, what resources that server is using, so you don't have to worry about it, but that's something to kind of know. Also, in this case, let's say we have two different companies. One is using the Mongo API, other one is using the SQL API. They are using the same server here. Just like the web browser, whenever you try to open ports or to open connections to the web applications, there's a limit, like 50 connections. If you want, or your application is really busy, you can actually override that number for Cosmos DB. So in that case, all you have to do here is in the documents clients, connection policy, and the max connection limit, that can go up to 1,000. But I don't recommend going to the 1,000 because that might be too much depending on the resources of your server. But you can easily change the connections in the same time connections to Cosmos DB by changing that. Second one, which is the recommended way, is the direct way. So in the direct connection, we are using the TCP and we are using TLS. So probably you will need to go to your IT department and change the settings for your firewall for this, or to open the ports for it to work. In here, as you can see, we don't have a network hub anymore, and everything should be much faster. But in the same time, don't forget to have some good resources for your SDK wherever it lies, because right now, SDK is the one which needs to figure out which database has what data. Before, the gateway server was the one which was handling that. Now that responsibility is going to be your SDKs. And this is available only in .NET and Java for now. If you are using the SDK2, you can easily change your connection mode to direct mode by just overriding the Cosmos client easily. We have one more, which is the dedicated gateway mode. I think that kind of explains what it is. That's your server. You are not sharing that. So you might say that, well, why do I need that? Because you are not, actually sharing that. That means that you have to actually pay for it. And depending on your application's traffic, you have three options. You have small, medium, and large. So in this case, you are not sharing the server with anyone. And by doing that, really Cosmos DB actually gives you some more options or features to use. The first option actually they gave with this is the caching. So if your application is reading the same data again and again, or your data doesn't change that much, well, by doing the caching, you can actually save a lot of request units, which means money. So in this case, as you can see, this works only in session and eventual consensus levels. You can easily overwrite your transaction, so your database doesn't have to be like, for example, session consistency. You can run your query in session in that case. So in here, we have an application, try to read or point read the data. It goes to our server, dedicated server, and dedicated server gets the data back, and you pay some kind of request units for that X number. When you send the same thing again next time, well, this time it costs you 0 request units. So as I said before, that can save a lot of money if you are reading the same data or your data doesn't change that much. So how do we make that work? First of all, your SDK needs to be 3.2.1 or later. And you must need to first go and configure the dedicated gateway server. So I'm not sure if you can see it here, but there is, right here you have to go and actually pick the size of the server you need. It's going to be low, medium, or high. Pick it wisely because you cannot change it later. You can drop it and create a new one, but just pick it wisely because you cannot make a small one medium later, for example. When your server becomes available, then under the keys, you will see 2 more connection strings, and those will be the dedicated connection strings for your server. So all you have to do is just take that and put it in your application to use that. So if you look at the code, how that thing actually works here, as you can see, if you're in SDK2 or SDK3, in SDK3's connection mode, the default one is the direct. So you have to actually override that and make that gateway first. Then, in our request options, as you can see, I'm not sure what your database consistency, but I want to be sure that this is going to get cached. So you can make the session or eventual. That's one of the requirements for caching. And also, you have to tell how long this needs to get cached. And in my case, it's 30 minutes. I'm going to cache this data. So in the next 30 minutes, same query, whatever I'm passing here is not going to cost me any money from the Cosmos DB. Bypass integrated cache is new. I believe it's in preview. I'm not sure public or private preview, but by just making that true, if something is cached, you are really forcing to go and hit to the database even it's cached. In some cases, you can use that. So in my case, as you can see, my first time, I returned 592 posts in here, and it cost me 32.25 request units. Next time, when I run it, well, next 30 minutes, that's going to be 0. So as you can see, you can really save a good number of request units here. Next one is, let's talk about the Cosmos DB SDKs. So as I said before, we have the data, and data is distributed all over the place. Now, if you have any kind of aggregation, any kind of order by, or if you are trying to find maybe average of the ages, for example, well, as I said before, your data is distributed. So the server 1 has no idea what server 2 has. So how are you going to group by? How are you going to order by in here? So all the pressure here actually goes to your SDKs, because SDK is the central place all that data actually comes in. So in my case, I look at the select top 10, and I order by the view count. So all the data is going to come into my SDK, and SDK is the one which is going to actually make all that aggregation and give you the data. In this case, I think there are like 10 servers here. You're actually receiving, well, 100 documents here, but SDK is going to display only 10. So all that job that SDK is going to do, it can be, expensive. So you want to be sure that you have enough resources wherever the SDK actually lives, because there's going to be all kind of for each loops and all kind of memory is going to need to make all this work. So if you look at actually this is the JavaScript SDK from the Cosmos DB. As you can see, we have the query info data out there, and it actually senses what you have. So in our case, this is our query, and that query is getting rewritten by the SDK. To make it easy when the data comes back, it can make it easy to kind of order by or find the data it needs. So as you can see, it senses I have a select top 10 here, and also I have an order by. So depending what you have out there, SDK actually rewrites your query. If you are using the .NET SDK, there are a couple of things you really need to know. The first one, you want to be sure that your application is in 64-bit. Whenever you create a new project, usually it goes with 32-bit or any CPU. You want to be sure that it's going to be 64-bit, because that file you see out there, the service interrupt.dll, is available only in 64-bit solutions. So that one is pretty important, because whenever you run a query, you kind of need to create a query plan. And if you have the service interrupt DLL, it can do that locally. So you are really saving one request to Cosmos DB for that. So if you have in 32-bit, it needs to call Cosmos DB for that. Next one is the default trace listener. You want to be sure that you disable that in production because it can do kind of bottlenecks in the production. Also, the garbage collection, you want to be sure that you use the server mode, not the workstation mode. That can create problems too for you. And if you are doing any kind of testing in Cosmos DB, and if your request unit is higher, well, the website says 50,000, but I will recommend 40,000 or higher. You want to probably use multiple servers or the multiple to actually hit the Cosmos DB, because one computer is not going to be, able to handle that 40, 50,000 request units or higher. You are going to end up with 429s or all kind of problems when Cosmos DB can actually handle it. Those errors actually happens because of your server, not the Cosmos DB. Next one, we are going to look at the Stream API here. Stream API is available in SDK3, and it makes kind of the job much easier if you compare to SDK2 here. For example, in SDK2, we have the serialize and deserialize every time we get data from the Cosmos DB. So in the SDK3, if you use the Stream API, you don't need to do like this 2 steps anymore, and you get the data and just return it as it is to your client. So if you look at the details a little bit here, for example, that's the SDK2, and most of the people are using this. This works if you have the partition key or if you don't have the partition key. This works for both. As you can see, we are actually running this query here, and every time it looks like we are returning lists of sales. So every time you create that sale object, really, you are doing the serialization here. And when you are done with this, you need to return this probably as a JSON object. So that's the deserialization you need to do. So that's like 2 steps you are doing every time. In the stream, we don't have to do that anymore. But I guess the catch here is you must have the partition key. So you cannot have the cross-partition queries with stream. But if you have the partition key, this makes things much easier here, because as you can see, we are taking the data as JSON and returning as JSON here. So everything is much faster and easier. Next one is document client. Document client is really the door, I guess, going to the Cosmos DB. You want to be sure that you are going to use the singleton whenever you create the document client. The last thing you want to do is you want to create the document client every time before you call Cosmos DB. Main reason for that is, let's actually see what happens when you initialize the document client. The first thing is going to happen is it's going to call to Cosmos DB, and it's going to get your account information. Then it's going to create another request. It's going to get all your container information. After you pick the container, which container you want to get the data from, then it's going to go and figure out which partitions and the routings is happening in that container. So that's 3 requests. Your 4th one is going to be the query. So the last thing you want to do is you want to do this again and again and declare the document client every time. So just use a singleton. That will save you actually a lot of headaches if you use that. So actually, this is a great place to talk about the consistency levels in Cosmos DB. So when this happens, you have the document client ready. We know how many containers we have. Now, the consistency level is going to actually figure out where the data is going to come from. So we have a replica set in every server. That means that our data is available in 4 different locations. So depending on the consistency level, we might need to hit the leader or the followers. So that's the place that actually is going to decide where the data is going to come from each servers here. Next one is metadata requests. So this happens if you are actually creating, updating, getting the list of the containers, databases. You are not really doing any kind of operations, but you are really getting information about your containers, databases. So there are some limits here. Those are hard level out there you cannot change. So if you are doing this a lot, you kind of need to know those numbers. For example, you cannot create 100 containers or database per minute. Also, we have the request unit to charge 240. That's a system reserved. Doesn't matter you have 10,000, 20,000 request units. That number is always the same. So if you are reading a lot about your containers, databases, maybe you put them in a drop-down out there, or you are creating maybe like dynamically containers, those numbers are important to know because they will be, like limit for you. The best thing I can suggest here is, especially for reading, just cache those information. They shouldn't change that much, so you don't have to go and get them again and again from the Cosmos DB. And those are the metadata calls for these limits here you see. Next one is optimizing the bandwidth. So especially when you are inserting data or updating data, usually you take the whole object, your data model, or you send it to Cosmos DB. You might be changing maybe only one property on that maybe big data model, which is fine, but what happens is when your request is completed, Cosmos DB returns that back to you in the response object. Most of the people, really, they don't really need that object. So your data model can be large. The last thing you want is your response packages, gonna be large. In this case, what we can do here is we can force Cosmos DB to not attach your request object to the response. So the things will go much more smoother because request object is gonna go and Cosmos DB is gonna give you only what happens is gonna be 200, 400, whatever you are trying to do with the HTTP code, rather than all the object you just sent to Cosmos DB. So to make that work, all you have to change is actually this property here, named enable content response on write. And you can make this especially on the bulk load too, if you are doing it. That's the last thing you want to do in the bulk load. So you can easily make this false, and you can do this in transaction level or database level if you like. And that will actually help your packages to go much faster because you don't have to send and get that same data again and again. Next one is the partial document update. As I said before, when you update something, in older days, you had to send the whole data model. So if you are maybe changing the property, I don't know, let's say you are just updating the address from something to another address, you have to send the whole data model. In this case, you can only send what you want to change to the Cosmos DB. That makes the packages much smaller, so things will work faster. But this is not really going to, save you any kind of request units. This is mostly for the developer to kind of make things much easier in the developer side. Because if you really think about it, in Cosmos side, it's going to do the exactly same thing. It's going to open the, the object, update it, and send it back to you. So this is really mostly for the developer. You can combine multiple operations with this. You can add a filter, which is very useful in some cases. I will have a demo for that one in a little bit. And it supports all the conflicts if happens. It's same the conflict resolution supports here. And if you are doing any kind of transactional batch, especially, it's very useful for that too, rather than sending the whole object, you can just send partial document. So those are the operations you see here. You can add, set, replace, remove. Increment is an interesting one. For example, if you are going to change the number of orders, maybe it's 1, you can just increase by 1, or you can decrease by -1. So you can easily do that. Or if you want to change a property from one location to other location, you can use the move for that too. So let's see this in action. The first one here is a simple one. So as you can see, I am creating a list of patch operations here, and I am adding the sale date to my data model, and I am removing the original sales date. So that's all I'm sending to Cosmos DB. I'm not sending anything else. But for this thing to work, Cosmos DB is going to require from me the document ID and also the partition key. So those two are important and required for partial update to work. The next one, which I talk about the filter. So in this case, what I'm doing here is I am still passing my ID and my partition key, and I am adding a new property named audit. And audit is true only if the number of items are larger than 5. So that will actually go through if that filter is true. So that's very useful. In some cases, you can actually add and remove things like that very easily by using the partial update. Next one is indexing. So indexing is important. We have 3 types of indexing mode. And when we talk about the indexing mode, in Cosmos DB, we have 1 index file and 1 data file. Data file is where our data is, and index is all the indexes you create for it. So really, the indexing mode is controlling the consistency level between those two files. You should always use the consistent, because that means that your data is always matching your index file. So if data changes, immediately index changes. Lazy is available out there, but many people might use that because lazy is cheaper than the consistent. But it can give you a lot of headaches and a lot of problems, because by saying lazy, you are really saying is data file eventually matches the index file, which means index file might not have the same data with your data file. So you might create all kind of problems, and you might not know why you don't see the right data and other stuff. Lazy is really not a good option for anything, really, I can think of. So if you're using lazy, just change it immediately. And none, that means we don't have any indexes. That can be useful, especially if that's the first time you are pushing the data to the Cosmos DB and you don't know what should get indexed yet. The last thing you want is, index the whole thing, because when you actually open a new collection, everything is getting indexed in Cosmos DB. So probably you're going to go back and exclude stuff anyway, so it's much easier to keep everything in none. Also, it can be useful if you are using Cosmos DB almost like a Redis. You have a key and you have a value. Your key is usually going to be the partition key, and probably you don't need to index the value in that case. So it can be none, and that will actually make things much faster because, well, if you are none, that means that you don't need the index file. Your inserts, updates will be much faster because it doesn't need to sync all the data in the same time. So we have 4 types of indexes in Cosmos DB. Range index is the most common one, and it really kind of handles most of the operations in Cosmos DB. Composite index is a good one. If you have a lot of data and your where clause is maybe having many filters, composite index can really save you a lot of request units. And also, if you have an order by, and if you want to order by with multiple properties, you must have the composite index. If you don't have it, it won't let you do that. Geospatial indexes are available, and those are only for the geospatial data if you have. And geospatial data will not get indexed automatically like the others. So it's going to be your responsibility to create those geospatial indexes if you have any data. Vector indexes are the new ones, just came up on the NoSQL API, and they are useful for the vector distance system function if you are using it. Currently, that's in preview mode. It looks very promising, and I'm really excited about that one. You can kind of create all kind of dimensions. So right now, everything is depending on the GPT model you use. You can actually create custom dimensions with this and change the dimensions if you like. So the next slide is going to be about the composite indexes, because composite indexes can save you a lot of request units if you use them in the right way. But there are a lot of catches out there. For example, composite index can optimize only one single range filter. And that range filter has to be the last filter in the where clause. So you might think that you are using a composite index, but you may not, because the way that you are querying the data. For example, let's look at these examples. So it looks like we have a composite index for the name and the age. So the first 4 rows is using it fine, because as you can see, the name and age is actually ordered in the right way. And we have one range filter, which is looking the age is larger than 18. That's the last one, so which is good with the composite index. So those are working fine. But if you look at the one in the 5th one, it looks like we have the same composite index, but this one does not want to work because the C name we are saying is not equal to John. So in that case, we have almost like 2 range filters here. So this is not going to work, and you are not going to be able to use that composite index. Then we have last 3 ones here. Looks like we actually have 3 filters this time. The first one works fine because everything is in order, and the range filter is the last one. But if you look at the one in the middle, this one doesn't want to work because the range filter is in the middle. And because of that, Cosmos DB is not going to use the composite index. So there's all kind of details here. You want to be sure that just because you have the composite index doesn't mean that you're actually using it. You just want to really see it's matching your signature of the composite index. To fix that problem, as you can see in the last row, actually I have two composite indexes. That actually fixes the problem because I am actually doing it in different properties here. So you can easily fix that like that. Then it comes to the modify indexes. So if you are using SQL Server and going to the NoSQL database, and usually in the relational database, you create a table, and it's your responsibility to kind of figure out which columns should be indexed. And nothing is getting auto-indexed. In Cosmos DB, when you create a collection, everything is getting indexed. And this included paths, as you can see, this asterisk is actually controlling that. So that means good because that's a no schema database. So if you are going to have more properties coming up later, those will be automatically indexed as you add them later, so which is good. But I guess my suggestion is whenever you are ready, your application is working fine in production, just go back and look at all your where clauses and figure out which paths you are not using at all. For example, you might have a description and you have a chunk of data in it. That's the last thing you want to probably put an index on it, because at the end, if you're going to do the indexing for everything you have, your index file potentially can get larger than data file. That means all your inserts, updates is going to get much slower and much expensive because it has to go and actually index everything in a different file. So you want to be sure that you're going to exclude whatever you are not using out there. Also, you might have 15, 20, 25 servers. So whenever you try to update your indexes, the last thing you want to do is you want to change your indexes just like SQL Server. Usually, you create one index. When it's done, you go maybe create another one. In Cosmos DB, you want to all do them together because, well, indexing is kind of like expensive in Cosmos DB because if you have 20 servers, that means you have to index 20 servers. And that can take time. For example, if you're a web application, let's say you have 1,000 request units per second. And your web application is using maybe 800 every second, so you have like 200 left. Cosmos DB will use that 200 to actually complete the indexes. So potentially that can take days to actually complete that indexes, depending how much resources you have. That's why, yeah, it's free, but you are really kind of paying for it in some way. So it's important to, I guess, change all your indexes in the same time. Throughput, that's the one that you actually pick how much request units you are going to need from the Cosmos DB. And we have three options. And the best way to actually explain this to you, let's say we are actually throwing a pizza party here, right? When you pick the provision, you know that how many people are coming, so you can order exactly how much pizza you need. So that's really the provision. You know the traffic, you know how many people are coming to your application, and you request that much request unit from the Cosmos DB. If you know the number, that's a great option. I like the auto-scale option because in the auto-scale option, you are, rather than, I guess, giving number of the pizzas, you are really giving a budget to Cosmos DB. You say that, you know what, this much I can afford, and as people comes in or they don't come in, you order the pizza for me. So you don't have to worry about what's really happening. For example, tomorrow might be like a big day for you. You are going to actually have a great, big sale. People are going to jump into your application. If you have the auto scale, you can easily kind of say that, okay, I want the 10,000 request units, but today you are only using 1,000. So the Cosmos DB will be responsible to scale up and scale down application as people comes and goes in. Serverless is a great option, especially in dev, QA, or if you have any kind of Azure functions out there. Maybe they run once or twice a day. In the serverless, really, I guess if you compare the pizza party, that will be like you sell the pizza per slice, really. So what's really happening here is you buy, let's say, 1 million request units per month, and you use it, and the Cosmos DB subtract that from 1 million every time you use. So it can be really a cost-saving option if your application is not really demanded all the time. Also, I'm sure most of you come here to kind of learn some way to kind of save some money with the Cosmos DB bill. Without changing any kind of code or any kind of knowledge, I can recommend this coupon for you. So Cosmos DB has a reserve capacity. And if you are using 1 million and less request units for your application, if you do 1 year reserved, they give you 20% off. If you do 3 years, that gives you 30% off without changing any kind of code or anything like that. So if you are sure you are going to use the Cosmos DB in the next 1 to 3 years, those are great options to just use them to actually save money on it. If you are using more than 1 million request units, that number can actually go up to 60% in some cases. So just check it out because you don't really need to do that much to actually save money with this one. Next one, this one is actually new in preview right now. You can actually do priority-based executions. So whenever you execute anything, everything is in high level right now. You can have 2 levels. So if you have a web application, maybe it's very write-heavy application. You don't want to lose all the the writes, but you have a couple of reads too. So you can easily say the reads should be low and the write transaction will be high. So just like the going in plane, there's a priority out there. The write will be always high in your case. And if something needs to fail with the 429, that will be the low transactions. So you can have some kind of control like that. This one works just like this here. So I have the item request option here. And I'm making this one, whatever I'm posting here, is priority level high. So there's a low and high. You can easily kind of control that. As I say before, this is still in preview. So this is not ready for the production, I guess, but you can really try it and give some feedback to the Cosmos DB team. I'm sure they will be happy. So this is all I have right now before I show some demo for you. But the demo I'm going to show you, I'm not sure if you already know it or not, but you can download it from there. It's a free VS Code extension that I developed. And that's my contact information. If you'd like to contact me later, I'll be more than happy to answer any of your questions. So with that, let me actually open the VS Code here. So when you open the VS Code, you can easily download it from here. If you search by my last name should come up. It's free, no charge out there. And right now, I believe I have almost 12,000 downloads on it. So many people are liking, and there's a good feedback on it. So the first thing it's going to ask you how you're going to connect it. You're going to put your connection key out there. Then it's going to list you all the databases and containers of each database. So in this case, I have the Stack Overflow here, and I pick the posts. Those talks, I talk about the physical partition and other stuff, but there's not really easy way to go to Azure portal and kind of show them on how it works. So that's the main kind of reason I started this extension. This one is going to make you easy because when you click the partitions here, for example, for this container, you can see how many physical partitions actually this one has. And you can also see these are the hash numbers of each server. So in that case, I think for the post, I believe the property post ID is my partition key. So partition key is going to get hash every time you are running or getting the data, and it's going to be between, I think this is the 0 here, and this is the FF, so it's going to be between that number. That's how Cosmos DB is going to know which database server actually has your data, and it's going to send the request there. So this one actually makes it easier for you to see what you are really dealing with before you run any kind of queries. So if I'm going to run really something simple like that, just give me select top 10 from the post. If you execute that one, so I get the data here. It tells you how much request charge for you, and you get the 10 items. But if you remember, I show you the SDK is actually the one which is filtering stuff. So you can easily go here, execution metrics, and see how many requests actually happen in the backend. I had 5 physical partitions. You see 10, but actually I got 50 documents. So SDK was the one which filtered 40 out and showed 10 to you. You can easily click on this if it's more than 1 and see how much request unit each server costed for you. So that's really for some people it's an eye-opener because as your data is going to get larger, this problem is going to get bigger, because you're going to have more servers, and each of them is going to give you more request units. So this problem is going to get bigger if you don't have the partition key. Also, this application can give you the point read, the one that I show you. So if you pass 2 numbers here, this will actually give you the option for the point read without writing an SDK yourself. Rather than that, which I believe last month, index metrics went generally available in Cosmos DB. And you can actually see that here. You can just click this one here, and you will see a new tab, indexing metrics. So if you have any kind of query like this, so if I run this one here, this is going to actually suggest if it needs any indexes or not, and it will show you if it's using any other indexes. So as you can see, I just search by the type and the score, and it's using the type. It looks like I don't have the score, so if you actually click the indexing policy, looks like score is excluded. So you can easily see what is in your indexing policy and which indexes your query is using by using the indexing metrics here. If you do that by the SDK, you can do it with the SDK, but the only thing I don't like in the SDK, it just sends the data to you in a chunk of text. So it's not easy to figure out. You kind of need to read it manually. You cannot really categorize what is utilized, what is not utilized. So as we talk about the indexes, so in here, I have actually the same data in multiple places. So if I'm going to run this one in the post tree, you can actually see what's really happening. So this one does not have the score. So if I'm going to run this here, this is only one physical partition. You will see your request unit is going to be pretty high because, well, score is not indexed. Looks like 322. So what you are really doing this, if you compare this to SQL Server, this is a table scan. That's what we are doing here. And this indexing metrics is actually showing that to you, that you are actually missing that. So it's pretty important. So if I go, for example, to post 2 here, which it is indexed out there, you will see a big difference because at the end it's a database, right? You want to be sure that everything is indexed. It went back to 9.78. So you want to be sure that all the properties unit are indexed, and if you are not using them, you exclude them, the right ones. And indexing metrics can actually help you with that a lot. So if you will have time, please, I guess get it. As I said before, it's free. It can do much more than that here. It supports all kind of stuff. So I'll be more than happy to kind of get feedback from you. And I just want to kind of share that with you. But that's all I have. Please let me know. If you have any questions, I can try to answer now or later. And thank you again for coming to my session. Thank you.